Academically, I've got 10
Okay, we need to
unlock it.
Yeah, I don't know. Can we have the AV person right away?
Yeah, it was really too bad during bands because it kept covering critical parts.
Especially that first one. During events, yeah.
Congratulations, great turnout. Lots of people online.
How many? I don't know how many people are online.
It says 90. It's pretty good. I could just see it when on Zoom.
Okay.
Right.
Yeah. Yeah, no, I mean, it's a packed agenda, not as much time for discussion as we'd like, but it's inevitable, right? Just, we can do a 3-day. That's really you want to sit during the Q&A.
That's fine. I don't care. The only thing that's challenging is for the people can't see each other across here.
We just wasn't trying to. Oh, okay. Yeah, you just have to. Okay, cool.
We're splitting time on this.
So the first we pull up the first top.
Oh, I'm sure time among your panelists. I can keep time with that.
I thought everybody was given, 10 minutes?
We said 10 minutes.
Okay.
Yeah.
So they have the instructions.
Okay, and is that the time for your introduction as well?
I'm going to try and do it.
All right.
Resume the recording.
Can we put up her presentation? Let's see here.
by DA January in the middle. I have a couple of slides just to make some comments.
Okay. So here, I need to do a quick intro. Very quick. You can just kind of see.
Great.
And then is there a way to...
Yeah, we can
do you want to just move it up into there? You know what you're doing.
It does help when you've done 4 million Zoom, right?
Okay, we're going to get started in just a couple of minutes.
Like the last 5 minutes or something.
And we go to
Over somebody. This goes to meetings or
it's already This will all be a little bit out on the spectrum, right?
Yep, everybody. Post-lunch exhaustion. So if people could take their seats, that would be great. Thank you. So, seeking to capitalize on the momentum from this morning's panels, and we're going to roll right into our afternoon. Hopefully we can make it through till the coffee break. For those of you who are craving coffee, it's on its way. If you don't have it, it will be here after our next two panels, which are both going to focus on impact attribution. So, to moderate our first impact attribution panel, we have Professor Chris Ebi. Chris is a professor at the University of Washington Center for Health and the Global Environment. She has been conducting research and practice on the health risks of climate variability and change for nearly 25 years. She focuses on understanding the sources of vulnerability, estimating current and future health risks, and designing adaptation policies, among other things. Like our other moderators, she has an extraordinarily impressive publications list, obviously, and among many other publications, she's an author on numerous reports, including the 4th National Climate Assessment, the 6th Assessment Report, and the Special Report on Global Warming and 1.5 degrees. So with that, I'll turn it over to Chris. Thanks so much.
Thanks so much. I could tell you got the introduction off the web because time moves on, and that was written pre-COVID. So as you heard, we're turning now to why does it matter? And there'll be 2 sessions then talking about the so what. And I just want to make a couple of points before we turn to the panelists. The first is health has been part of the discussions around detection attribution from the beginning. That health as a field does attribution, has been doing attribution longer than this community. And so there were several health scientists at a meeting the IPCC conducted, an expert meeting, during the 5th assessment cycle. And so some of what you see in the methods used today actually came from methods that are typical in health. I have a couple other points to make if this wants to move forward. Okay, how am I going to make the slides move forward?
Delete the arrow key.
The arrow key is not doing anything? It's going too far. Okay. I want to make 2 points that are important for the discussions we're going to have. The one on the left is framing used by the IPCC for quite some time, pointing out that as we look into the future, we're looking at risk. And risk is composed of probability times consequence. In the framing of the IPCC, there's 3 main factors that come together to form those risks. The hazards created by a changing climate, which we talked about this morning, the exposure of human and natural systems, and then the underlying vulnerability of those systems. For health, it makes sense to separate vulnerability into susceptibility to harm and the capacity of our health systems to manage. And this complexity then makes the question of detection attribution more complex. The right-hand side is one of quite a large number of figures that show the very wide range of the health consequences of a changing climate. And this is only a short list. There's hundreds of climate-sensitive health outcomes that can be affected by climate change. And so it's a rich area for exploration in terms of detection and attribution. To underscore the point of the complexity, we need to take into account exposure and vulnerability. We know that where you live in a city determines how hot it is. And so when you think about looking at heat waves, people in different parts of the city have very different experiences because it's hot. In most of our cities, we've had in the US redlining. Redlining is historic marginalization of black and brown populations, and that continues to have consequences today. Further, black and brown populations often live in food deserts where they don't have access to appropriate nutrition. They don't really have grocery stores, which leads to higher rates of chronic disease, which leads to higher vulnerability. And so thinking about how these intersect then in terms of conducting detection and attribution. Sarah Perkins Kirkpatrick just published this, and it's something that was implicitly discussed this morning. I think it's quite helpful to put it out explicitly on the table, is that detection attribution for impacts is multidisciplinary. There has to be joint discussions about what is the event. Why are you choosing this event? You're choosing it because there's concern about impacts. And so there has to be joint definitions. It can't be one side making the decision, because a decision about an event may not then be relevant for the impacts you want to look at. And so I encourage you to look at Sarah's complete paper, but this is a nice illustration of how we need to work together to do robust detection and attribution. With that, we have several panelists that will come up. I've put their names and their affiliations so that we don't have to do formal introductions. And Emmanuel, you're the one who's up first, and each of the panelists have 10 minutes. Sorry, did you want to go first? Shoot. Okay, we'll have Shuro first. I just put this up in the order that was in the list I had. So we'll do Shuro first. We did talk about that, didn't we? And I completely forgot. My apologies. All right, so we can get Shuro's slides up?
Mine's here. I'll go.
Okay, great. And you've got 10 minutes until 20.
Can those online see? Perfect. Thank you, Chris. Thank you, the organizers, for putting this great show on. I am an economist. I'll get that out of the way. Really not sure how I got the invitation to join, but here we are. I'm an environmental economist at the European Center on Climate Change. I'm based in Venice. Be jealous. My main areas are climate impacts on labor, food security, health, with a healthy dose of underlying inequality. I lead the EasyMIP sector for the labor force, and I recently led the health risk assessment for the first ever European Union climate risk assessment. It was legally mandated by the European Union. So, without further ado, the labor force. Labor damages or labor accounts for a substantial share of total value added, as much as 50%, depending on sector and the country. If our goal, or one of our goals, is to use evidence for climate litigation, labor is one of the top candidates, or should be. We can show attribution on individual labor impacts at sectoral level, we can show at industry level, and we can show at more regional aggregated levels, be it subnational or country. Heat stress, as we know, is already having adverse effects on the labor force. Our latest research, as we'll see some of it today, quantifies the extent to which changes in labor, different components, be it labor supply, number of hours you work, labor productivity, your effort during this number of hours that you can work, can be attributed to climate change at the global level, but also at regional focus.
I'm sorry to interrupt. We need to share the slides online. To ensure that we're sharing the old deck of slides and not the current. This is your.
No, this one.
This is. Oh yes.
Yeah. You can just double click, I think. Perfect. Sorry about that.
Thank you.
Yeah, thank you. Yeah. It's okay. So we'll see regional focus and industry and sector focus, but also we're not focusing on projections, but these impacts are projected to be substantially worse under future climate change. Slides. Okay. Here we go. The ILO estimates that 2.4 billion workers out of a total global workforce of 3.4 billion experience excessive heat or heat stress at work. They also estimate about 23 million occupational injuries and about 19,000 deaths. And based on our conversations, they have admitted that this is a very, very low estimate or very underestimated impact. This figure was recently published in a paper I led, published in Nature Reviews on Earth and Environment. We looked through thousands of newspaper reports, and we found that occupational deaths are far higher than what ILO estimates, which are based on official numbers. More than 20,000 workers are estimated to have died in 2022 due to heat stress at work. But ILO says less than 20,000, but again, we can attribute changing climate or climate change to worker deaths already. So climate change is affecting your human right, which is a guaranteed human right to safe and healthy working conditions, right? So this is established one factor. This is not for today, but just to show our empirical foundation for the attribution work we're showing. We combine more than 300 microsurveys from more than 10,000 subnational regions. We estimate our own response functions, which has been the weakest point in climate and labor impacts research for the last 30 years. And then we estimate the response functions at the sectoral level, sector by region, and then this is what we do. We combine this response functions with EasyMIP data on attribution to compute changes in labor outcomes for the observed period, which is 1901 to 2019, and a detrended no climate change period. What we can show already is that a clear and measurable negative impact of historical climate change on the labor force, be it labor supply, number of hours that people work, labor productivity, their effort during those hours, but also a combined metric of these two. Globally, effective labor, which is a combined metric, as I was talking about, is more than 3 percentage points lower during 1998 to 2018, and this is at the global level, right? So if we go regionally, the impacts are obviously much higher. Attributable negative effects due to temperature increase during the last 40 years or so has been the highest in Western Africa, nearly 10 percentage point decline, Southeastern Asia, more than 5 percentage point decline, Middle Africa, more than 8 percentage point decline. So these are already numbers that we can provide here. And then we take our labor impacts, attributable labor impacts, to economic effects. Because let's face it, this is what policymakers care about. What's the damage on GDP? Most regions experience a steady decline or have experienced a steady decline due to declines or negative impacts on the labor force. Highest losses are in Southeastern Asia, nearly 20% in 2018 in the high exposure sectors, so agriculture, construction, mining, quarrying, forestry, and so on. In the low exposure sectors, even in the low exposure sector, we see a lot of negative impacts. The largest loss in Western Africa. So low exposure sectors will include manufacturing and utilities. Work mostly undertaken outside in the shade or indoors, right? Again, we have translated impacts on the labor force to economic effects. As I was talking about, we can show individual impacts, sectoral impacts, country level impacts, and now impacts on the GDP. Some implications. This is only a starting point. Remember that socioeconomic attribution is still at infancy. Apart from health, that has been going on for a while. You know, if you're talking about labor or economic effects, we're only just starting to do this. However, we certainly believe that this is a good starting point for climate litigation evidence. We have evidence at the global level, the regional level. We have micro-founded evidence coming up based on several countries, including South Africa, Kenya, India, Bangladesh. Anywhere a labor force survey exists, we can work on it. And currently we have about a list of 40 countries that we will be publishing over the next couple of years. We have several PhD students working on this. And again, the other issue is that we quantify costs of not mitigating, and of course the global co-benefits of investing in mitigation. It's a win-win situation. If we focus on protecting the labor force, it improves labor productivity, improves profits, improves GDP at the end. The other part is that we're trying to work on is transition or just transformation, whatever you're talking about, whatever term we use. It is the big elephant in the room right now, and there are growing concerns about potential mishandling of just transition strategies from governments, labor unions, and a lack of protection for workers in general. We strongly believe that our work on attribution can address some of this concern by providing evidence on how climate change or historical climate change can be attributed to labor force negative impacts. At the social level, societal level, labor force impacts increase intra-regional inequalities, right? Especially because the impacts are highest in the high exposure sectors, as we've seen, agriculture, construction, where workers tend to be the lowest income earners, right? This often lead to poverty traps. Again, it's a vicious cycle. Highest impacts in high exposure sectors where incomes are lowest, they face heat-related stress, they get sick, can't work, their income reduces, and the cycle goes on. With that, thank you very much.
Thank you, Shiro. That was really great.
Thank you.
Manuel's going to come up. And while he does so, I realize I was not clear. Health has been doing attribution studies for a very long time, but not in climate change.
Yes.
Look forward to your talk. Do we have to reshare the screen when we shift the slides?
Yes, it's sharing specifically the slides and not your screen. So to avoid having all the extra stuff around the edge of the Zoom.
Okay, so
Okay.
you'll pull up your slides and then reshare it.
You have to go full screen first.
Okay. All right. Yes. Perfect. All right. Thanks. Hello, everyone. Good afternoon, and thank you for the invitation. Just like Shuro, I don't know why I'm here, but we'll try and figure that out. And I'm a sociologist by training, and for the last 15 years, trying to understand why and how people are impacted by disasters. And part of the question that I have been trying to investigate is especially looking at question of vulnerability. And I think what I will talk about will lead very well with what Chris and Shuro have been talking about. But not presenting solutions, but actually complicating the problem a bit more. And just like Chris sort of set the scene to present sort of the puzzle around how do we disentangle these different drivers. And just like Chris said, I think disasters are at the intersection between risk, hazard, exposure, and vulnerability, but oftentimes what we get focused or what gets spoken about is the hazard, and we forget oftentimes about the risk, vulnerability, and the exposure that come together, which is what we see often within climate reporting or within the media, within the headlines. We often see the word natural disasters, and I think that's what we've been trying to disentangle, saying that disasters are not natural, hazards, but hazards also are unnatural now. So how do we talk about unnatural disasters? Freddie and I wrote a paper in 2022, right after COP27, trying to sort of look at the attribution studies that were done in that particular year, and then taking two examples of how vulnerability sort of sits at the very center of why and how people are impacted by these disasters. And these are often socio-political processes, colonial structures, oftentimes lack of sort of infrastructure to be able to cope with these disasters that oftentimes puts people in harm's way. One of the biggest concerns is how do we disentangle these various drivers of vulnerability and exposure. And over 60 years of disaster research clearly highlights how disasters are products of failed development processes in most contexts. Climate change worsens these impacts during disasters putting many people and societies and countries in cycles of disasters and development. I think that's exactly what Shuro was referring to now, in terms of how it's beyond the ability of certain communities, households, and countries to be able to recover from these disasters, which becomes a cycle of disasters annually. What then happens is that we normalize risk. So, for instance, earlier this year in 2024, my team and I were doing fieldwork in India, in Chennai, where we see increasing impacts of heat waves. But Chennai is also known for being a very humid place. So when you talk to local communities and then we talk about heat waves, people would say, it's always been hot, so what? So the language around heat waves hasn't really penetrated within sort of when we see these impacts, because risk has been normalized in many of these places, which is extremely problematic. Many of these places are also built on marshlands with poor infrastructure, thus making exposure a very critical part of the impact scenario that we're talking about. The question we have is, how do we disentangle these different factors? However, while no access to better infrastructure puts people in harm's way, repeated exposure to climate-related disasters every year puts them in a position to not be able to adapt and cope anymore. What happens is that then recovery periods take an extremely long period of time. You can't often measure. Part of the problem is also because these impacts are not seen only in the immediate aftermath of these disasters, because a lot of focus is within the first 3 months of when we do sort of impact studies, it's within sort of a very short time period, but people have impacts over, it could be months, it could be years, the loss of a home, the loss of someone within a household, emotional well-being, stress. Many of these factors don't manifest in the immediate aftermath of the disaster, or even if they do, they take a very long time to recover from. What we also see is it's important to look at these impacts not just from the perspective of the hazard, but the ability and inability to cope and adapt to these disasters, which goes back to the question of vulnerability and the continuous cycle of disasters which exacerbates vulnerability. I'll give you 4 sort of factors that we've been trying to understand from a very qualitative perspective. I'm glad Shuro presented a very quantitative idea of some of these things. And for instance, these communities that we've been working in Chennai earlier in 2024, in some of the resettlement areas, would talk about cycles of debt. So you go from a flood, an unexpected, unprecedented flood, and in a span of 3-4 months, you move into a heat wave. So you sort of borrow, when there's a flood, you can't go out to work, which means, and I'm talking of daily wage laborers, which means that you lose a day's income. Now, what do you do to cope with that? You have informal money lending mechanisms. So you borrow money. Over time, that continues to build, and then you move into a period of heat stress. And during heat waves, it's the same informal wage earners who would say, there is work outside, but our body physically doesn't allow us to work the 8 hours or the entire day. What does that mean? That means still reduced income. So you sort of are in a continuous cycle of borrowing, putting people into cycles, decades of debt in some places. There's a loss of wages during the flood and the heat in the same year. If we look at school children, there's a loss of school days, and I think there is a number of initiatives now, hopefully very soon we'll see that, for instance, in the context of education, of how many days in a year do kids lose to school because of various kinds of hazards. And what does that do to education in the long run, and what does it do to children and well-being, both in a short and long-term perspective? Another aspect of loss of wages during these events is also sickness and illness that comes up during these hazards and disasters as well, which we only talk about from a very short-term perspective, but the long-term is often forgotten. What am I getting at? Qualitative material can provide rich descriptions of these impacts. How do people cope and suffer? How do people move and see impacts from one disaster to another? And how much do people cope and why they cannot cope anymore? What is it that's really tipping off this sort of putting people in cycles of debt for a long period of time. We've been using seasonal calendars, for example, to map out long and different impacts of these disasters spread out in an annual cycle over a number of years. When do people fall into debt traps? And we're trying to triangulate that with interview and other forms of data as well. We see varying degrees of impacts within the same region, and part of what Chris referred to of if you live in a certain part of the city, what does it do to you, even within sort of a very close geographical space, how different communities are impacted differently. They take a long time to manifest and even to recover, and sometimes never recover before the next disaster comes. How do people cope with loss of a home, mental well-being, and many other factors that actually cannot yet be measured in the short span of time? One big gap area that we see globally is we do not know much about any of these questions in conflict settings, for example, globally. Freddie's team and myself, some of us have been trying to work with attribution studies in conflict settings, and we know how difficult it is. It's a huge challenge to be able to do attribution work in many of these conflict settings, let alone empirical field work, investigating some of these questions that I'm talking about. We are just kicking off a new project in Kenya funded by the Danish Ministry of Foreign Affairs, asking some of these questions. What happens when heat wave impacts informal settlements in Nairobi, Mombasa, and some of these cities? What happens when heat intersects with drought within agricultural communities? As I speak here, one of our PhD students is presenting a poster in one of the old train stations in Copenhagen showing sort of that the amount of heat wave studies that we have in Africa, what kind of impacts, who are the vulnerable communities, based off a large scoping review that we've just taken off. But over the next few years, we will be unpacking some of these questions through empirically led studies by some of our students in Asia and Africa as well. I'll stop here for now, and thank you for your time.
Thank you. That was a very powerful presentation and an excellent example, as was Shuro's, of why collectively there has to be definitions of events for detection and attribution. Jonas? Let me see if I can move this so I can. All right. So you know you have to pull up your slides and then reshare.
My PC skills are similarly weak.
There's two versions.
There's two versions. Let's see. This looks good. It says share here first.
Share. Yep, you got it.
Yay. All right. Thank you, Chris. Thanks, everybody, for having me. I could put myself on the row. I don't know why I'm here, but try to justify it. My name is Jonas Jägermeier. I'm with Columbia here, Columbia Climate School, and NASA Goddard Institute for Space Studies. And I lead a global crop modeling initiative with an AgNIP, and also the agricultural sector in ECMIP. So what I'm trying to do is shift the discussion for a moment on food and agriculture. And what I was planning to do is share a couple of insights and early results and challenges from such impact attribution work. So don't expect a full holistic review of climate impact attribution in agriculture. This is evolving and preliminary. So what we're usually doing is we're looking forward. We're using climate models and trying to evaluate how climate change affects global agriculture. And as we do so, we have realized over the last 10 years that the uncertainties associated with climate impact science are tremendous and actually much larger than the underlying climate model uncertainty. So we are adding a layer of uncertainty that is complex and unsatisfying at moments. So this animation here shows an average of a large ensemble of 5 climate models forcing 12 process-based crop models each. So we're creating a multi-model ensemble, which we think is one of the approaches to use to address those large uncertainties.
And as we look at these animations, you see stark differences in impacts across regions, across crops. So the first message here is that climate change in agriculture isn't a blanket of adverse impacts. There will be losers, there will be winners. It's a very complex, messy picture. It's definitely not straightforward. And now we're going to try to put all of that in context of attribution. While we're doing these long-term average projections, we also learned that the interannual variability, the fluctuation between years, is increasing. And that can have tremendous impacts on your food systems, on livelihoods, on trade systems, on prices, and whatnot. So here measured as in CV is coefficient of variation, but the maps highlight that even in regions where we see average increases in wheat yield, our interannual fluctuation tends to increase as well, potentially destabilizing a system. At the same time, we all know that from climate projections, the intensity and frequency of heat waves and droughts is expected to increase in the future. Here, under two different CMIP6 scenarios, specifically for heat waves, we see a drastic increase in frequency. So what we did first, before looking into the future, is looking backward. And Cordesk, who used to be with us at NASA GIST, and one of my PhD students, Teresa Brass, looked back, used national observations of crop yields, and then selected years and countries where we had disasters happening from the EM.DOT database, overlaying those events, creating these composite figures. And they both show the same thing. Over the course of the last 50 years, 60 years, the impacts of heat waves and droughts have increased. The impacts in agriculture, in commodity row crops, have substantially increased. Now, this is a question, it's not necessary, the conclusion isn't necessarily that this is a change in hazard. It can be, but it can also be a change in vulnerability and exposure. What if we have pushed into domains that we haven't cultivated before, that we haven't settled in before? What if we're doing different agricultural practices that make us more vulnerable? So the question is, how can we explain such a trend? And then obviously the next step is then to look into the future and use climate modeling to understand how those impacts will evolve in the future. Now coming back to the modeling, shifting away from observational data, we confirm. This is a multimodal ensemble of 6 process-based crop models running globally, evaluating the same impacts of these EM.DOT disasters that were recorded and shown in the previous slide. And indeed, the model confirms these observational data. We see a lower impact of droughts and heat waves before the year 1990, and then an increased impact of 2% in heat waves and almost a doubling in the impacts of droughts for events after 1990. So this takes out the uncertainty around how events are measured. The models confirm that there is a hazard component and an exposure component. Now we want to turn to attribution. And one thing we have to understand is that using climate models in an impact model environment is often leads to internal variability that's not leading to the best results. So climate models are known to underestimate extreme events, and the internal variability is often not sufficiently explained to explain observational data. We're turning here to a new product that is specifically designed for impact attribution work, which is a reanalysis product, so an observational-based weather record based on a detrending method to create a counterfactual that is non-probabilistic. So if you want, it's a pseudo-observational approach to actually do event attribution, because a 2012 heat wave occurred in our observation, but it also occurs in our counterfactuals. Now it gets a little bit complicated. If we run those through the crop models, again, this is a 6-model ensemble, we see a lot of noise. We see that the simulated yields increased over the course of the century, which is in line with observations. We see that yields leveled off a little bit over the last couple of decades, but then we need to look very closely to understand a little bit of the signal here. So, as some of you may know, carbon dioxide in the atmosphere is very important for crops. So the higher the CO2 concentration, the more crops can benefit in those environments and can grow faster and bigger. Not so much maize, but for wheat, this is very important. So if we include a scenario that is a factual minus the CO2 component, the blue line, the purple line, that's our CO2 effect. And then the counterfactual one in yellow sits in between. So that delta between purple and orange is the net climate change effect. And my apologies, this is a little bit technical, but I want to show you how complicated this all is. So within the range of a factual minus counterfactual, you have to look very closely if you want to understand what's happening in agriculture. For wheat, the signal is actually much more pronounced, as wheat is very sensitive to CO2, so our factual runs off. And the difference between factual no CO2 and counterfactual, or a true climate change effect, is very small. But remember, this is at the global aggregated levels. Once we start looking more regionally, we see a lot of changes happening that cancel out at global level. Now I want to conclude on the focus on extreme events, because here we actually do more of a signal. So as average changes disappear in global aggregation, the analysis of heat wave impacts does actually stand out. So in our gray line here that's hidden behind the green line, we show observations. So the factual simulated in green and the observations are very much in line, which is building confidence in the models. And then a counterfactual based on those detrended pseudo-observational data indeed highlight that the impacts of historical heat waves were significantly lower in a world without human forcing. For drought, the picture is more complicated, and I'm going to leave you with that. We can discuss, but it doesn't mean there is no climate change signal here. It can mean a lot of things. It's just complicated. Oh, indeed, this was the wrong presentation, because I did have a summary slide, but also we have a discussion coming up, so we can get to some of those points. The main thing is, I guess, that I made clear is it's complicated. Climate impact attribution is way more complicated than climate attribution. There's a layer of additional complexities and uncertainties that we are factoring in. It's observational data that are often missing. It's the uncertainty of the crop models, and it's the climate component itself. So the method of detrending or probabilistic, non-probabilistic counterfactuals is very important. Thanks. Sure.
You can come down. Let's see if we can close all this off so the people online. All right. Cheryl, you're down there. Manuel, you're with me. All right. You know the drill. It's now time for questions and answers. And on the impact attribution, we would appreciate some answers. And I can't see half of the audience. Yes. In white.
Hi, my name is Soledad Aguilar. I come from Argentina. I had a question for Jürgen. Jonas, sorry. When I saw your maps, obviously coming from Argentina, I was looking at Brazil and Argentina, the Amazon basin, and the growth. There's a little part in the top that was growing in the production of agriculture. My question is, how do you incorporate in the models deforestation? Because those are areas that are currently forested. And whether that is incorporated in the model, the movement of the agricultural frontier, but also afterwards in the carbon dioxide cycles. Because if if that forest goes out, then you have more emissions. So how do you, how do you do these loops in the models?
Yeah, thanks for that. That links directly to those complexities. And for simplification and for understanding the system, we're separating climate factors from anything management or agricultural practices or land use changes. So any of the material I showed is based on the assumption that management components are held constant. We deliberately isolate the climate signal so land use change is not incorporated. We're using the same extent of cropland, the same management, the same fertilizer application, the same irrigation infrastructure throughout the whole set of simulations. So it's not factored in. It will add to the picture later, and then in an adaptation scenario, it becomes really important because no adaptation assumption is obviously wrong. But it's also important to understand the climate drivers first before you start messing up the system even further.
Everything was perfectly clear. I don't know what to do about that. Do we have any questions? Oh, thank you. Okay, question from here.
Thanks for these talks. My question, I think, is for both of the last two talks, or sorry, first and last talks about, so the first talk about labor used what seemed to me to be primarily statistical models, so fancy correlations between climate variables and labor output or labor supply or labor productivity, whereas in AgMIP you're using these process-based crop models where you're actually simulating crops, simulating the climate influence on crops, the CO2 effect, and so on. How do you all think about the relative benefits and costs of statistical, sort of what you might call top-down or sort of macro-level aggregated statistical models versus process-based, potentially more computationally intensive models that are actually sort of simulating the processes that give rise to crop growth and crop loss in a climate change context?
Sure. You want to start off and then
So very much context specific, right? So for socioeconomic attribution studies, such as the one on labor supply or labor force, you have to rely on econometrics or empirical foundations, right? The other option would be going to, let's say, something like an SEM, but those aren't yet equipped for attribution studies, right? Whereas for the process-based models, whether for crop yields and so on, I think we have sort of reached the plateau of statistical analysis on those topics. I'll hand over to you. So my answer is very much context specific, but for labor force, that's how we know we can get to the attribution part.
Yeah, same vein, we have to be aware of strength and weaknesses of each model. There's no wrong model or but it all depends on the application case. If we're looking at long-term climate change impacts, a simplified statistical approach is probably not as strong as a fully process-based empirical understanding of this underlying system. You're pushing your model out of your sample case and you're coming up against questionable results. However, for short-term analyses, think of seasonal forecasting, nowcasting, anything looking back, explaining management trends and data gaps that we don't have, where we don't have the data available. An empirical model can actually be very, very handy and fast to explain and help come up with those answers. So it really depends on the context. For attribution, I'm a little bit split. So there's, you can make a case for either way. The one thing I will say is that I don't thoroughly enjoy the camp situation. There's an empirical camp and a process-based camp, and I think that's the wrong approach. I think we have to start using the models in a way where they're beneficial and potentially even combine them. Now including machine learning based approaches. They are very powerful on the outcomes of a process-based model. Process-based models are great, but there's a lot of things that they can't do. Flooding, for example, is a blind spot in crop models. Now, if we use the outputs of a process-based crop models and run those on a machine learning-based approach, that's where we get a really powerful model.
I'd like to add from the health side, the statistical models incorporate any recent changes in terms of control. And so if the question has to do with spread of a geographic range, for example, of dengue fever, if you use a statistical model, all of your control programs that have been established over the last couple of decades are now part of your baseline. And that becomes then problematic. So there is more an emphasis on process-based models to get away from embedding too much into the baseline that is influencing the answer to the question. And as both speakers said, you have to look at the question. Go back to my first point of this is why we need to work together to define these questions, because we're hearing significant impacts, significant factors that impact the decision. And to work together to understand the different consequences of using different kinds of models and how best then answer the question you'd like to address. Yes, please.
Thanks, this is great. So part of what I understand why we're here is because we want to connect attribution science with the legal context and increase the fluency across these disciplines. And so it's an interdisciplinary endeavor. Impacts attribution is a very interdisciplinary endeavor. As you move down the impacts chain, you go from the physical change to the hazard to the impact itself, which is different data, different methods, different ways of generating knowledge. And I just wondered what the lessons learned are from this kind of impacts attribution that might be transferable to this context that we're in right now of trying to connect law and attribution science.
I'm happy to start on the health side. There's the few detection attribution studies that have been done in health are incredibly powerful for moving policy. That as a professional, I can now stand up and say people are dying from climate change. I'm not talking about associations, I'm not talking about possibilities, I'm talking about facts. And that then can flow into the legal context as well, because we can quantify. We may not be able to quantify who, but we can quantify the numbers of people who died in heat waves, including Freddie on the Pacific heat zone. And in the state of Washington, an event that was virtually impossible without climate change killed more than 440 people. Those are 440 people who would not have died otherwise. And so it's incredibly powerful for the impact communities, which then can connect to the loss and damage, it can connect to the legal issues. But the ability to do these quantifications gives us the kind of power that the climate science has experienced with doing the fingerprinting, doing the DNA studies, and being able to come forward with more justification for the urgency for actions.
Yeah, to add to this, to the labor context, the labor unions are increasingly interested in attribution studies for collective bargaining agreements. And OSHA, so EU-OSHA, they're very interested in using attribution studies once they're published to include them, to push through essentially the idea that heat stress needs to be included in labor protection policies. We're surprised that how out of the 176 labor protection policies or labor acts that exist, only 4 explicitly mention heat stress. And the main reason they're not explicitly integrated is because the courts strike them down, saying there is no evidence. So this is what we're trying to push for.
It's also true in prisons
Yeah.
in the U.S. Kevin?
Just to follow up on your point there about the 440 deaths associated with the heat dome. Now, there would have been a heat wave anyway, and people still died during heat waves. So the key question is what's the marginal number of people that died because of the climate change? You can't. I don't know that you can attribute everything that happened, because things would have happened even if it was a non-climate change enhanced thing. So how do you do that?
That's an excellent question, though. I'm trying to get the health sector to try and engage in, not very successfully so far. In this case, the event was so extreme. It was, might be interesting, it was accurately forecast, but nobody could believe that an event that extreme could happen at that time of year. The city, the county did quite a job to do what they could without being prepared. But specifically in that event, and Freddie's the one who can talk about the detection attribution of the event itself, that it is a question of if it would have occurred anyway, but at a normal level, there's very low mortality in the state of Washington from heat waves, because our heat waves are not very strong. Right? And so the mortality baseline is pretty small. And you could take away from the 400, you could look at this in terms of the PDFs, but that really hasn't been done. There are a couple of ways to get to that question, and that's where I think the community needs to go to have that specificity. Freddie, did you want to add anything to that?
I mean, of course, it's the heat wave as hot as that was impossible without climate change. I agree, there would have been a heat wave, and I think that is, I think actually, you said we can't tell you who died, but we can give you the number. I think probably we can actually do the opposite. We can tell you who dies, that, based on what Emmanuel was talking about, and also you actually in your introduction. I mean, not necessarily by name, but which are the people, where do they live, what characteristics do they have? But to give you a number that you can really stand up in court, I think that's the much more difficult part, because it depends on a lot of assumptions and a lot of stuff that actually is really difficult in the impact models. But we can say, for absolute fact, people have died, and it's these people that live in the shitty housing that are not reached by information and so on. And I think, for me, the interesting question is, how do we maybe turn the court cases so that that's the information that can be used? I don't know, maybe, sorry, you asked me a question and I ask a different question. Well, maybe Emmanuel can speak to that.
And go first. So one of the challenges with heat waves is half of all the excess deaths are from cardiovascular causes. And trying to figure out, we can say that half are from cardiovascular causes, that's a main cause of death in the US, right? And so trying to figure out what you just said is actually very hard. You can figure out the red line districts, you can figure out particularly vulnerable groups, but there's a large group that would be hard to sort out because it's such a common cause of death. And you don't know which of the people who showed up in an emergency department showed up because of the heat, and as a consequence they're having a heart attack, who showed up because they're having a heart attack. The emergency department's goal is to save every life that comes in. And teasing that apart is something that is pretty complex. But for the highly vulnerable groups, we can do exactly what you said. And we've got Shura, we've got Jonas, and Emmanuel.
So, and again, we know much of the challenges in the context of the labor force. Nearly 6,000 workers died constructing stadiums for the fancy, beautiful Qatar World Cup, right? Only one of those 6,000 postmortem reports mention heat stress. Everything else was, all the other mentions were parsed out, but one stood because that person was wearing a vest and we could see in real time what happened, right? So that's the challenge we face we're talking about Qatar, in the US, in Texas, they're abolishing water breaks. Of course workers are going to die. What do you expect, right?
Yeah, I just want to come back to the original question of tangible outcomes and conclusions. And from the agricultural perspective, we're not there yet. I think I made that point. But that doesn't mean there aren't robust qualitative conclusions. So the agricultural sector has produced a lot of evidence over the years that, for example, climate change impacts are worse in the global south. That's a fact. In in the global north and in temperature-limited regimes, a moderate amount of warming can potentially lead to benefits. That's also given. And we know that some crops fare better than other crops. We know that certain management practices can make your system more resilient. All those things are reliable and can lead to policy decisions. But to quantify the number of deaths that happened during a recent famine, and to pinpoint that to the climate change contribution, I don't think we're quite there yet.
I agree with what Jonas and Shura had to say, and just to add to what Shura was saying, we were working with domestic workers unions in Chennai, and it's exactly the same story. They're really struggling to sort of bring in aspects of disasters, particularly heat waves, into collective bargaining agreements, to sort of use that. And we were working with informal workers, which means we're working with daily wage laborers who don't have the same collective bargaining. Collective bargaining is a loose word for them, right? So these are very organized informal sector in some ways. And it's really an uphill battle. Part of the challenges coming from the global south is some of the challenges that Chris mentioned, and part of it is also reporting. I mean, lack of hospital data, lack of many of these things to be able to say some of these things more inclusively. The third thing is, I think Freddie referred to it, we have a similar forum in Europe that we're part of, an interdisciplinary forum where we're trying mainly people coming from different disciplines trying to understand each other's language. And what we realized there, one of the lessons learned from there is that we're all having very, very different understandings of even causality, responsibility, vulnerability, and I think we've been spending about the last 18 months or so just understanding one another over different Zoom calls and what some of these terminologies actually mean, what holds up in the code of law. What do lawyers mean by a quantitative assessment or a qualitative assessment, and many of those things. So and like Shuro said, I think particularly the socio-economic, political aspects of how do we integrate that is in a very, very nascent stage.
You know you've got Freddie's name tag?
Administrative matters. So this is great. It's interesting to me that you each said you didn't know why you were here when it's so obvious to us why you're here. So just to maybe follow up on Justin's question from before, I'm not sure. So I'm one of the lawyers in the room, and I'm hearing you're saying we're not quite there, and that it's very complicated, and that and so forth and so on. And the thing that's coming to my mind is, well, why not, right? So is it a modeling question? Is it a confounding factors question? And I think that's really my question, is about confounding factors in how you disentangle hazard, vulnerability, and exposure in these contexts sufficiently to attribute a particularized impact, whether it be, labor or crop impacts or other impacts. Because as a lawyer looking at it, it seems to me like maybe that's the stumbling block. Like, is that right? Is that what's too hard here? Is disentangling the climate from the confounding factors, or are there other things going on?
So, thank you for this. I'll connect this to the first question. One of the strengths of statistical or empirical modeling is that we are able to control for those factors. For labor, I'm confident that our studies will hold up in the court of law because we can disentangle the climate signal, the weather signal, from the socioeconomic signal. We will be able to tell you, or we are able to tell you, how a heat wave day or extremely hot day affects an agricultural worker compared to a construction worker compared to a utilities worker, right? So this can hold up in court, and again, as an economist, it's hard for me to say that, but the next battles for us are not going to be in the top 5 journals. It's going to be in the court of law, and this is what we are preparing for. So at least for the labor force studies, we are ready.
All right,
it's been too long, right? So.
No, I don't think it's the disentangling of confounding factors. I think we're pretty good at isolating the climate signal, and we're pretty naive about, let's do that first, and then we mess around with the rest. No, it's about confidence, and I can give you a number. I can give you a median number and walk out the room, but I can't do that with confidence. And we're running multi-model ensembles for that reason, but they're all over the place. That's the problem. It's model uncertainty, impact model uncertainty. And if I gave you the range of responses in those figures, they're just all over the place. And that's the number one reason why we're so shy about those results, is that there's a lot of compounding factors, a lot of data limitation factors. And then I want to put out one other reason, and that's institutional funding. So look, for example, at NASA GIS, we're 150 employees, plus or minus. Most of them work on a single climate model, maintaining the climate model and running it. And what about the crop model that I run? I have a postdoc and a PhD student, and they move on and leave undocumented code. And we're putting them on the same page, but it's a very unfair comparison. So in terms of funding, emphasis, and structural support is not there yet. And how do you expect the uncertainty in climate impacts to be reduced without the same form of emphasis that the CMIP has done 15, 20 years ago? And that's why we do AgMAP. That's why we're trying to formalize the impact sector a little bit. But we're just simply not there yet.
And I think just to add to that, there's also an ongoing conversation about how do we sort of move, not just looking at the impact on the hazards, but then moving into looking at how do we actually truly disentangle the impact of the disaster in itself. And that's where the socio-political, the structural issues become even more complicated. I was just talking to Chris about saying, I think we're talking a lot about heat waves, but this is much more harder to do when we look at other kinds of disasters and hazards. I think there's a lot more progress within the heat wave sort of studies in the last couple of years, but we haven't gotten there with many of the other hazards the same way.
And I want to really underscore Jonas's point, no funding.
Yes.
That Wellcome has just funded the first series of detection attribution studies for health. The worldwide literature on detection attribution climate health is about 15 because there's been no funding. And without serious funding, then we're just not going to be able to further develop the models, even develop the conceptual thinking on how to collaborate across the sectors. And the funding, I will go beyond what you said, it has to be multidisciplinary. And in Europe, you've got centers of excellence that work together. In the US, we're just all compartmentalized, and you can't get funding out of NIH to do work with someone in climate because they don't think that's their permit. And it's a challenge. And so I think advocating for that is important. And then finally, an advertisement is, I did have funding from Wellcome. Ben, Rachel, and others were at a workshop, and we're going to have a guidance document later this year on detection attribution for health, depending on how long it takes to get through a journal. And I've got one question, and then we also have to say how many people online have their hands up?
We have a few, including one from Joyce.
Oh, excellent. Joyce, why don't you take your question first, and then we'll go to Joyce and a couple of people online.
Great, thanks for these great talks. Marshall Berg, Stanford. This is one of those annoying comment posed as a question. I actually think we're in a lot better shape than, my view anyway, than some of the uncertainty that you guys implied. I think in a lot of different impact areas, so labor force, I'm glad you stood up for your labor force estimates, labor supply estimates. I think we're there in ag, right? Our statistical models have really, really small standard errors. Maybe you don't think so in the process-based models, but if you're willing to trust statistical models, like we can be pretty darn confident about what happens during a heat wave for agricultural productivity by the end of the year, right? And we can do that around the world. We have a lot of data on this. We can do it pretty well. As you said, Chris, on the mortality side, right? I mean, decades of really good work in epidemiology, showing, with exquisite detail at the city level, at the neighborhood level, what happens to excess deaths during these events. I actually disagree with Freddie a little bit. I think we're going to be much better at saying the overall number of deaths with confidence than we are with who died specifically. So I think we're actually good at the excess death number. We're bad at saying who it was. But I think we can deliver the excess death number or the yield loss number or the labor force loss number with a lot of confidence now. So I think we should stand behind that. And more funding is always great. I want that funding too. And I think there's a lot we can say even absent funding. That wasn't a question.
No, that's great. That's encouraging.
No, it's good. Confidence and uncertainty. I'm going to get hammered for saying this in a place with so many scientists. But what I was presenting, it was an internal seminar, and someone commented online. She works with the labor union in India. She said, "You guys talk a lot about uncertainty, and I understand it's important, but we're at the knife edge. Does it really matter how uncertain you think your estimates are if I'm going to die working outside because I don't have a choice?" We do have to think pragmatically as well. We spend so much time talking about uncertainty and models and confidence bands, but we also have to think, as they say, on the ground sort of thing.
We've got questions?
Yeah, so Joyce has clarified that her question was answered in subsequent discussion.
Such a shame.
We have a question for Dr. Raju. Your research highlights how multiple climate-related hazards can compound each other's impacts on human well-being. From your perspective, how can policymakers and practitioners better anticipate, measure, and respond to these cascading and overlapping hazards in a way that accounts for vulnerable populations, promotes social equity, and ultimately strengthens long-term resilience? An easy one for us all.
Well, I guess that's the entire question of the IPCC's work in some ways, in many ways. I think there's a lot of question around, and for decades, for instance, if we take the question of adaptation, I think in Freddie and I, in our paper in 2022, we write, for instance, adaptation itself misses, a lot of adaptation conversations misses the point about vulnerability. And I think that's also part of the discussion now. For instance, people like Lisa Schipper, Aditi Mukherjee, who talk about how do we sort of not weaponize adaptation, but actually use adaptation in a way where we also talk about vulnerability at the heart of some of these things. Which means that when we talk about adaptation, we're not only talking about actually the climate, but actually talking about vulnerability and socioeconomic questions in addressing adaptation. Because oftentimes when you respond to disasters, disaster response and recovery often is about establishing status quo. And when you establish status quo, it means that you're recreating risk. So the only way to break that cycle is to sort of really question responding to disasters the same way that we do. If we don't establish status quo, then there's an opportunity to actually say, how do we do things differently?
There's a tool that can be used mostly at the local scale, but can be used at broader scales that comes from the military. The military does war games, I don't know how many times a day, but they engage regularly in war games. For sectors, it's stress testing. And it is thinking about creating future events that are beyond what that community has ever experienced. Bringing together all the relevant stakeholders, people who would be affected, to have that conversation of, if this occurred, what is it that should be done today to prevent it in the future? And these are for exactly that kind of planning. To say, this event was designed so we can't manage it, but that doesn't mean we can't become prepared. And so using a different kind of tool, a toolkit that's being used by the banks, it's being used by many other sectors, to think a bit differently about the preparedness. One of the challenges we face is humans fundamentally are really bad at looking at the future. We just have a hard time imagining a different future. The future is going to be different. The story I love is about Thomas Watson. When he was head of IBM, was presented with the first personal computer. He got a full demonstration of it. He watched all of this and pronounced the worldwide market for PCs was 10. When my kids were at home, I'd cornered the market, right? We won't talk about today. But we just can't do this very well. And so thinking about different tools to help people think about a future that's going to look fundamentally different from what we're in right now.
Just to add to what Chris is saying, I think a lot of disaster response recovery mechanisms oftentimes talk about lessons learned, but actually does not incorporate foresight and the future of saying, okay, how do you sort of meet the demands of the future to be able to actually be more resilient?
I suspect we can take one, maybe two more questions, one more question.
So we have one more question
Oh, perfect.
online, which has been in part answered throughout this conversation, but gives us an opportunity to close. So each panelist has named several challenges to attributing impacts within their each specific areas of specialty. This questioner is wondering if we could go down the line of panelists and have those, name them again, identify areas of critical research, so that we, as the audience, can be thinking of a relatively complete list of challenges that need to be addressed as a scientific and legal community.
Wow.
It's a very small ask.
Each name one.
Sure, you want to start?
For the labor force, it's going to be connecting heat stress to occupational injuries and mortality. So we know more about the supply, so let's say the economic components, than we know about the, let's say, human part of it. That's the challenge.
I'm going to emphasize the data point one more time. If we don't know what's going on in the field, we can't model it. So it's really important to have an improved representation of what's going on. And that starts with planting dates, that plans with management practices, and that ends with yield observations. Sometimes we only have national yield observations that are spit out by an agency, and we have no idea what's behind it or what influenced those numbers or who made up those numbers. So it's a big component of what we're doing is all about data.
I'll add the funding, but it's got to be multidisciplinary funding for centers of excellence where we can all work together. There's, as you see from the number of people here who are online, there's a lot of interest in this. And there's lots of scientists that could contribute significantly to the challenges that we've heard. And the reality is funding's required to make that happen.
And to add to what Chris was saying, I think a lot of that funding and a lot of the capacity, a lot of the studies that many of us have mentioned here is partly and mostly in the global north. And I think what Joyce was talking about is the fact that you cannot do many of these studies available. So a lot of funding added to actually also some of the places that don't have that kind of funding, institutional capacity to be able to do the kind of research that we're talking about as well.
That's great. It's a little after 2:15. Should we? Okay. We'll have a coffee break later for those of you who have other questions. Let's thank the panelists. They did an amazing Sorry.
Great, thank you so much, Chris. You ready? Okay. All right, so we're going to move right into our next panel. It's my pleasure to introduce our next moderator, Peter Fromhoff. So Peter is one of the first people I started talking to when I started working at the intersection of attribution science and climate law and policy, and has been a frequent collaborator over the years, so it's a real pleasure to have him come up here to moderate our next panel on impact attribution. Peter is currently a lecturer at Harvard University and a senior science policy advisor at the Woodwell's Climate Research Center. Previously, he was the Director of Science and Policy and the Chief Climate Scientist at the Union of Concerned Scientists. He's been a lead author on the IPCC Fourth Assessment Report, on the Special Report on land use change, and forestry, and many, many other papers along the way. So with that, I'll turn it over to you, Peter. Thank you.
Thank you, Michael, and hi, everybody. So this second impact attribution panel follows really nicely on the one that we just heard. This is going to focus on natural ecosystems and natural systems more broadly. And I think you'll find that the discussions in the panel really will be synergistic with, complementary to the previous discussions. And I think, as Mike, as you had said at the outset, the order in which these are being presented is somewhat ad hoc. Some of these could have gone earlier, some could go later, but it will really look for opportunities to draw lessons across the broader set of two panels after we hear these presentations. And so I'm going to introduce our speakers and then give them an opportunity to speak to their topics. And so first up, we'll have Jason Smerdon. Jason is a professor of climate here at the Columbia Climate School, speaking on drought today. Followed by Rachel Warren. Dr. Rachel Warren is a professor of global change and environmental biology at the Tyndall Center for Climate Change Research at the University of East Anglia, speaking on ecosystems and biodiversity. And finally, Nick Ogden, who couldn't join us here in person, but I think we'll have him available virtually. We'll take a deep dive at a particular focus with respect to disease vectors, vector-borne diseases, and looking at evidence for impacts on climate change's impact on Lyme disease emergence in Canada. So with that, let me turn this over to Jason, and we'll start off. Thanks, everybody.
All right, now it's my turn to embarrass myself. I can't actually see the screen. Is the screen off again? The screen is off. It'd be great if it was on. I think this is a bit of a crazy angle. Where's the share? There it is. This is harder than it looks, trust me. It's like the angle here and stuff. Is that working? All right, there it is. And does my pointer work if I use it? Can you guys see that? All right, if anyone cares to know, I'm here because my colleagues know me as someone who is constitutionally incapable of saying no. So that's why. I'm going to take the liberty of starting out by saying this is hard. I work in various cross-disciplinary communities, and this is hard work. I feel probably the same as many of you, that the language that's being used, the questions that are being addressed, depending on your discipline, are foreign. But I don't want to underestimate the importance of fostering these discussions. So I want to thank the organizers and everybody that's in the audience for taking the time and the effort to do something that's hard. I think this intersectional space is critical, and I'd like to think of these kinds of conversations as the beginning of a longer conversation where we learn how to speak to each other. We learn the kinds of questions that each of us ask, and maybe ideally in the long run, we learn how to ask different questions together. So I think that's our motivation. So with that as some context, I thought of you as all lawyers today as my audience, because one of the most important things in giving talks is knowing your audience, and when you don't know people, that can be difficult, so that's another hard part. But the idea was for me to talk about drought detection and attribution, and the way that I thought about it is to give you a sense, particularly of the difficulties we face in doing drought attribution and detection, and Jonas gave me a great intro in this in the context of ag saying it's difficult. So I'm going to talk largely about the physical characterization of drought, its detection and its attribution. Of course, it's also an impact, and the way those impacts cascade through natural systems and health systems and so on is something that I hope the other discussants are going to address in their presentations, but also hopefully we'll seed some things to have discussions around in the panel discussion. So I'm going to start with the punchline and just show you the latest assessment from the IPCC around drought. So this is circa 2021, and this rather crappy figure assesses where drought has been detected and where it can be attributed to climate change. So if you can see my pointer, these hexagons here are supposed to roughly mimic the outlines of the continents. Here's North America, here's South America, here's Europe, Africa, Eurasia, etc. And if there's a color in one of the hexagons, this is a place where where a drying or a wetting signal has been detected. So if it's brown or tan, it's a drying signal has been detected,
And in Northern Australia there's a wetting signal that's been detected. Lisa, you will be happy to know that the detection threshold here is greater than 50% chance of that signal being detected. So a couple things to note, there's a lot of places with crosshatching where signals cannot be detected at that threshold. There's a lot of drying regions, there's one wetting region. And then the other thing to note in this figure is the dots within those regions. So if there's one dot, there's really low agreement in any kind of human contribution to those trends. If there's two dots, there's a medium level of confidence, and you can really see that the only places where these signals have been detected have medium confidence of an attribution signal in them as well, and there's no high confidence areas. So this is like the IPCC's assessment, which is human-induced climate change has contributed to increases in agricultural and ecological droughts in some regions due to increased land evapotranspiration with medium confidence. So there's a lot to unpack there, but what they're saying is that these increases have been detected in specifically droughts, so these drying regions, and they specifically say agricultural and ecological droughts, which means drought signals in soil moisture. And the agriculture and ecological differences are just the biomes in which those drying signals have been detected. And they're attributing it specifically to evapotranspiration, which is not necessarily a change, well, is not a change necessarily in precipitation, but is something associated with the drawing of moisture from the land surface through the transpiration of plants or evaporation at the surface. So the causal mechanism they're pointing to is one that's driven more by temperature than changes necessarily in precipitation. So medium confidence, not a lot of areas. Why is that? I want to give you a sense of some of the challenges. And so that's what I want to leave you with is some of these difficulties. So to do that, I'm just going to give you a couple examples from the research that we've been doing in my group. This is work that's been done by a graduate student, Andisha Shamara, in our group. And I want you to digest this figure. It is a timeline along the bottom going back to 1901 up through 2023. The shading lines, there's two different scales. So the scale along the left is a global drought index that we've defined to assess the severity and the extent, spatially, globally, in drought occurrences over this time period. And the green and blue are for wetness areas, those regions where we've looked at the severity and the extent of wetness areas. And the different shadings here just have to do with different thresholds, so significance thresholds of these deviations. Not really that important. But when you look at this assessment over the last 100 years, and by the way, this is based on a soil moisture estimate. We do not have soil moisture that goes back to 1900. This is a data limitation. We estimate it from atmospheric variables. We use a model to estimate the anomalies that we would predict from those atmospheric conditions and create an estimate of soil moisture anomalies back in time. And what we find, if you look at this time series, particularly along the top, where more extreme drought and more extensive drought is down, you might see some trends, you might not. Specifically the last couple of years, and what I'm actually asking you to think about is we've had a lot of droughts, severe events in a lot of different places over the last several years, and you might ask the question, just naively, were those last couple years out of context, or were they anomalous relative to the historical period? And you can kind of see an uptick in these last few years. And so you might conclude from these time series that, well, it looks like 2023, 2022, 2021 were particularly anomalous in terms of the global extent and severity of droughts on the planet. But this is what you do if you ask that question and use different data sets. Now, we can't go back as far as the beginning of the century. We're using products that are satellite-derived, model-derived, that start in the early 1980s. And what I'm showing here is same kind of a figure, but the shading in the background, this brown here, is the data that I've already shown you. And then these lighter bars here are estimates from different data sets. Different, for those of you in the know, GLEAM, ERA Land, MERA, and SPEI, different estimates of soil moisture back over this time. And if you look at this, there's definitely some similarities, but there's some differences in the way these things represent the last couple years, the way they may represent trends. And so one of the first uncertainties that I want to communicate to you is the data that we have is very difficult. We've heard this in lots of different contexts, but specifically in the context of drought, the amount of soil moisture observations and estimates that we have is quite limited, and actually estimating changes in soil moisture over time is quite difficult. And so we have limited time periods, and when you look across these different data sets, you may come to different conclusions. So this is the dreaded table slide. But what I'm showing here is the rankings from 10 to 1 of the different years using these different data sets. And you can see that 2023, 22, and 21 all rank highly across these data sets, with the exception of MERA, where they're not as present. Only 2023 comes in. And when you look at these data sets, and if you were to try to answer this question, was 2023 or 2022 or 2021 a significantly ranked drought, you'd be hard-pressed to come to a definitive conclusion. They look like they rank high, but depending on the data set and where they fall, is going to create different questions. So the first thing I want to leave you with is that the data sets are a challenge. And I've already run out of time almost, so I'm going to jump forward and say something about the other aspects of drought that's challenging, which is that it's not just a single variable. I've been talking about soil moisture, but there's lots of different processes that contribute to dryness in the land surface. And it may be the case that a drought is driven by precipitation, or is driven in soil moisture, or runoff is affected. And there's lots of different interrelated processes, all of which may individually be affected by climate change. And ferreting that out can be a big challenge. We've done a lot of this work in the American Southwest, where we've looked at the mega drought that's been coined and characterized there over the 21st century. And the point I want to make in this space is we've looked at the signals in precip and temperature in that region. And if you look at the precip signal here, so this is highly variable precip in the Southwest. This green line is that model-derived estimate of the greenhouse gas force changes in precipitation over the Southwest, and it's basically a flat line. So in terms of the precip signal in the Southwest, these anomalies that have been observed there over this megadrought interval are largely the product of internal chance, internal variability within the climate system. But what you can also see in the Southwest is there's been a significant drying over this time period, which we can attribute very strongly, you can look at this green line, as the model-derived estimate of the temperature increases there. And so this is where these evapotranspiration influences come in and have made the drought more severe than if it was just naturally caused. So we can actually do the counterfactual. And Lisa, here's a number. It shouldn't just be this number, it should have a range on it, but we can estimate the counterfactual of what this drought, so in the late, or in the beginning of the 21st century, what this drought actually looked like through the observed estimates, and what it would have looked like without those human caused factors, and primarily the temperature factor. And what we've estimated is that the human impact on the drought was about 42%, made it about 42% more severe than if that human-driven temperature change had not existed. So first, another sort of take-home is that as we think about these variables that influence drought, some may have clear human detection signals and others may not. But there's, of course, other characteristics that we can also discuss. So another way in which this human-driven drying through temperature influenced the drought is to make it more spatially extensive. There were more areas in drought. These are drought rankings, and you can see this is the observational drought rankings, and this is if you remove that human component. So the human component, the temperature-driven change, made the drought more spatially extensive. This is a little bit complicated, but it made it more severe. I want you just to focus on the red and the blue lines. So this is the observed cumulative soil moisture anomalies in the Southwest, and this is if you remove that human component. So the cumulative soil moisture anomalies were more severe as a consequence of that primarily temperature-driven component. And actually, by our metric of when the drought started and when it ended, the drought wouldn't have even started in the Southwest until 2007 without the human-driven component. So what we're talking about here is attribution features that have made a natural event like this more severe, more spatially extensive, but it would have happened, just as we discussed in some of these other features, it would have happened in the absence of the human influence, but the human influence has made it more severe and more extensive. And I think that's an interesting, I hope that we can have this discussion. I've talked with some of you in the audience about how to think about that legally in the context of looking at these events as intensified, more extreme events that weren't just exclusively yes or no. All right. So one last thing I want to leave you with is the difference between a discrete event like a drought, which is often the way that we talk about it, but also these aridification signals. The signal in the Southwest, for instance, is much more of an aridification signal than it is a discrete event. And so we're going to have wet periods and dry periods in the Southwest, but the overall trajectory in the Southwest is projected to get much drier over time. And so I think there are also very difficult questions to ask how we characterize these discrete events when the baseline is changing. Because we always talk about drought in reference to some interval, and thinking about how we discuss drought as an event when that interval is changing is something that's challenging scientifically, but I'm sure it's also challenging legally. I think I've blown past my time, and I will cede the floor.
That's the shared with the online.
So give us a hand with the slide share, please. Oh, thank you.
There, the Zoom slideshow.
Here you go.
So, well, good afternoon, and first of all, thank you very much for inviting me to speak. So I accepted this invitation to speak because I'm really keen to explore how IPCC Working Group 2 science could potentially be used in litigation. So Chris by her session also refers to Working Group 2. So this is about climate change impacts, and not only the past impacts but also the future risks. And so not only do we perform attribution science, but we also identify what has been harmed and who and what could potentially be harmed in the future, thus identifying your future clients, I think. And ecosystems and biodiversity are actually one of the most impacted sectors, and we have very, very strong evidence already for the attribution of these impacts to climate change. And I would like to explore with you whether we actually already have enough information to take legal action on this. Ecosystems and biodiversity are critically important because they underpin ecosystem services on which human society and the economy all depend, and huge numbers have been quantified for the economic values of those services. And there are also interesting moral questions about whether species and even the Earth itself have a right to exist unmolested, and could that be represented legally? I do not know. So, going on now to what I'm going to cover here, basically I'm going to focus heavily on the outcome of IPCC AR6 because that is an excellent summary of the state of knowledge. There have been some advances since, but I'd like to focus on AR6 with a couple of exceptions. And I'm going to talk about some of the challenges that we face in trying to improve our knowledge of attribution. First of all, I'd like to remind everyone that all of this work is done under the auspices of the UN Framework Convention on Climate Change, Article 2, which states that we want to stabilise greenhouse gases to prevent dangerous anthropogenic interference within a time frame sufficient to allow ecosystems to adapt naturally. So here is one of the key statements from IPCC AR6. It is very likely, now this is more than 90%, that observed changes in the phenology, ranges, physiology and morphology of species can be attributed to climate change, particularly increases in extreme weather events. Now, I'd also like to draw your attention to the diagram below, and I would really like to explore whether this diagram, which in the IPCC we call the burning embers, could be useful for litigation. And the reason I say that is that this diagram, the y-axis here is increasing levels of global warming above pre-industrial, and the colours are demonstrating the level of additional risk due to climate change only. So all of the other potential drivers are not included there. This is climate change only. And also, when you look at the y-axis, you're going from the impacts we looked at in the past to the impacts that we project in the future. And as the colours get darker and more purple, the risk is higher. And this diagram that I'm showing here is one of the key outputs of the Chapter 6, the chapter on ecosystems in AR6, which was led by Camille Parmesan. And Jeff Price, one of my colleagues, was also in that chapter, and he and I put these slides together, hence his name is also on this presentation. And basically you can see that already with only about 2 degrees warming, which is in the relatively near term, you're getting to a very high risk of biodiversity loss. So this is something that is going to happen in the near future if action is not taken now. And I noticed that in the paper that Michael Berger and Jessica wrote, towards the end there was a mention of a possible for legal action about risks that were substantial and near term, I think. And that's exactly what we show here. Below the grey line, which is the present level of global warming of about 1 degree, you can see there's a lot of yellow. This means that impacts have been detected and attributed to climate change already. This is in ecosystems and terrestrial and freshwater only. We have these diagrams for every other aspect of climate change risk as well. And this moderate level of risk is actually basically more likely than not, which is perfectly what you want. So looking a bit more deeply into what AR6 found, where attribution was assessed, which is in about 4,000 of 12,000 species that was specifically looked at, half of those 4,000, the attribution came out with a tick. Yes, it was due to regional climate change with very high confidence. That means 9 out of 10. So higher than you need. And this is showing that across all continents and across most ecosystems, we have high or very high confidence, and if you take it down to the medium, which is the more likely than not, you can see it's almost everywhere on all continents and in most ecosystems. So what better evidence could you have than that? Now coming on now to wildfire. So clearly wildfire affects both humans and ecosystems greatly, but fire seasons have lengthened on 1/4 of vegetated areas huge, since 1979. Climate change has increased burned area by about 16% in the last 20 years. The area burned in the US has doubled, lots of increases in other parts of the world. As fire becomes more severe, it's more difficult for ecosystems to recover, and increases in fire frequency can lead to transformation of an ecosystem to another ecosystem type. And on the right, you can see the huge difference in the fires in the past that would have occurred and would not have occurred in the absence of climate change. So that's the counterfactual showing there. This also increases emissions. Wildfires generate up to 1/3 of the emissions coming from natural ecosystems, and the emissions have tripled in the last 20 years in the boreal forest, despite human efforts to suppress fire. The carbon combustion rate's gone up 47%, increasing forest fire emissions by 60% globally. And that comes from a paper by Matt Jones at the Tyndall Centre where I work. And this, of course, creates a feedback that exacerbates climate change, just showing increases in fire weather days in Australia. So coming on now to the methodology. So the earlier studies in biodiversity and ecosystems looked at detecting change and didn't do attribution. Then they looked at correlations with local changes in climate. And then they started doing something called double attribution, which is where you take the anthropogenic forcing, you take the natural forcing, and then you combine them, and you see which of those three actually can account for what I observe happening in biodiversity and ecosystems. There were a few very prominent papers in the fourth assessment report of the IPCC showing that the double attribution worked. One of those was led by Terry Root and Steve Schneider and Mike Mastron-Breyer. Steve Schneider was a mentor of mine, and it was from him that I took my title of Professor of Global Change and Environmental Biology. One often used but not entirely reliable metric is that human impacts on biodiversity and ecosystems are rarely unidirectional. Okay, that's not a great issue. I should like to also add actually that it was Steve who pioneered the burning embers diagram approach, which he actually put forward as a way of helping governments to decide what was dangerous anthropogenic interference in the climate system, which of course nobody could interpret before that. So it was those diagrams that really helped the governments identify 1.5 or 2 degrees as being levels above which they did not want things to go. So what are the problems in attribution in biodiversity and ecosystems? So we've got great evidence, as I said already. If you want to make it better, what stops that? Well, sometimes there aren't any weather stations in the places where species are being monitored, and reanalysis data isn't always perfect either. Then you've got, of course, confounding factors, although, as I said before, they're usually not unidirectional. And then the question is, okay, you identify a contribution, but how much is that contribution? And this gets particularly difficult if you've got 2 drivers like climate and disease, especially if climate is also affecting the disease, right? So an example is that the chytrid fungus is responsible for the extinction of many species of amphibians. And there is evidence also that warming increases the likelihood of frogs being infected. But separately, the models that we at the Tyndall Centre have run, and other people's models, show that amphibians are amongst the most sensitive vertebrate animals to climate change alone. So there's actually 2 separate drivers. They are independent, but they also interact. So what percentage of any local amphibian extinction can be attributed to climate change? Well, AR6 stated the interaction between chytrid and local climate change is implicated in the extinction of many tropical amphibians. And to date, 2 full species are thought to have gone extinct solely due to climate change. The golden toad, which went extinct in an area where there was no chytrid, and the bramble K. melamis, which lived on an island with no human population, and there were increases in inundation. And in both cases, it was extreme events that eventually led to the demise of the species, as also it led to the demise of the white subspecies of opossum. So sorry, I couldn't find a legal picture. This is a lovely animal. So extreme weather events, the subject of one of our other sessions, attribution of these events is very well done by people in this room. And this is very helpful for us because when we look at ecosystems, the ability for ecosystems to recover from extreme events depends on the size and strength of the storm and the length of the frequency of the storms. And AR6 did an excellent job of showing conceptually how much the models underestimate species extinction risk because we can't include the extreme weather events. So there have been some individual studies where people have looked at butterfly populations in extreme weather events, but basically the risks, if you include the compounding effects of extreme weather, are much higher. So what can you do to make things better? Well, the longer period of time you look at, the more you can differentiate from natural variability. The bigger the area you look at, the better it eliminates confounding factors. If you know what the mechanism is between effects on an ecosystem or a species, that really helps. Or if you know that it's a particular aspect of climate change that's the issue, e.g., I don't know, winter vernalization, that the winter cold going away, or heat waves, or whatever. Backcasting of models is rarely done. These are the models that project the risks into the future. If we were to backcast, we might be able to say more clearly what proportion of we've got with very high confidence in the impacts, but how much of them exactly are attributable to climate. Backcasting could help us do that. There are lots of local extinctions. Half the species examined have lost locally due to high temperatures, especially in the tropical regions and in fresh water. And some of these heat waves have led to mass mortality events. So, as I mentioned at the beginning, all of this matters hugely for supporting ecosystem services like nutrient cycling and soil formation, pretty critical for everyone. Regulating services, air and water quality, pollination, soil conservation, critical for agriculture, cultural and existence values, as I mentioned at the beginning. And finally, it's been shown increasingly recently there's a positive relationship between ecosystem services and human well-being, and there have been large economic values placed on the value of ecosystem services and their implications for human health. So thank you for your attention.
So we need to bring Nick on virtually. And let's see, how do we find him?
I am just getting the slides up.
Is that you, Nick?
It is me.
So you're in the ether.
I am in the ether.
Let's see. Do you want to give this a shot?
Sure.
Have fun.
Do you see that?
If you just return to Zoom, you should be, yeah, just click that.
Oh, I see. Sorry, it's different on here.
Oh, that's the problem.
All
Okay,
right.
good. I'll let you through it.
Sorry,
No worries.
I'm clicking on Zoom Workplace and it's not coming.
Odd.
There we go. Thank you.
While that's going on, I'd like to thank the organisers for inviting me and apologise for not being there in person. So, okay. So I'm going to talk about the evidence of impacts of climate change on Lyme disease emergence as a kind of to stimulate some discussion about impact or attributing changes in infectious disease and zoonoses and vector-borne diseases, which are known to be climate-sensitive diseases, to effects to climate change. For those who are not maybe as familiar as others, the Lyme disease is a bacterial disease transmitted by ticks. It's a vector-borne disease, and to have risk in your environment, you have to have a number of things together. You have to have the tick vectors. You have to have the reservoir hosts, which are small rodents. You have to have deer, which are main hosts for the adult ticks. And you have to have the woodland habitats, which provide an environment for all of them. And the life cycle of the tick is, well, it has multiple stages that feed and can transmit the bacterium. And that life cycle is unusually long for arthropod vectors, 2 to 3 years, whereas mosquitoes maybe just a few weeks of a life cycle length. But many stages of this are climate sensitive, which I'll talk about in a moment. So when we started to consider Lyme disease and impacts of climate change in about the early 2000s in Canada, what we knew about Lyme disease risk is that it emerged in the 1970s in the northeast and upper Midwest of the US, and most of the cases, and what I'll concentrate on, are the area where the tick vector is Ixodes scapularis, or the black-legged tick. And the risk areas were just over the border, so perhaps with a warming climate, those ticks would head northwards into Canada, causing a problem. So that's why there was focus. At that time, there were 2 known tick populations, or populations of this tick, on the north shore of Lake Erie, and one of them had been known to be in Canada for many decades. But that was pretty much it. And so we did not have Lyme disease risk, and that was not an absence of people actually going out and looking. It seemed to be an absence of tick populations. What we had learnt, or what we were learning as we were going on, is that, first of all, ticks are seeded into Canada every year by migratory birds heading north in spring from the US and bringing the US ticks with them. The field studies suggested the habitat is fine for the ticks. There's nothing inherently toxic of Canadian forest for ticks. The host density appeared to be correct as well, and not too low. So why, the question was, why had these tick populations not become established? Is it too cold, and will that change significantly with the projected climate? So there are a number of ways that temperature, and particularly cold temperature, can affect the survival of ticks. First of all, direct effect, if you put ticks in a freezer, they'll die. But what we've learned from the empirical study is that the ticks, if you place them into an appropriate woodland habitat, that provides refuges and prevents them from deep freeze. And so it doesn't matter whether it's minus 40 in the air, it's a minus 2 or 3 in the duff layer, and they can survive. So it's not the cold in winter. And we hypothesized that it was possibly due to the effect of temperature on the life cycle length, because temperature affects how fast the tick develops from each of its life stages to the next. So in other words, the colder it is, the longer is the life cycle, up to a point where there will likely be a threshold that the life cycle is too cold, the life cycle is too long, tick populations just cannot sustain. So we've built a mathematical representation of the tick life cycle, and which included a lot of empirical data on the impact of temperature on the tick populations, to identify, by a number of simulations, the relationship between temperature and tick abundance, and a theoretical one between tick abundance and temperature across the whole length of the life cycle of the tick, the multi-year, which is, and the metric we used is annual degree days above 0 degrees C, and to identify a threshold below which we think the model suggests you can't survive if you're a tick. We can then, using this threshold and relationship, map out at least temperature suitability for the ticks, and that was consistent with the idea that temperature may be determinant of the reason why we didn't have tick populations at that time in Canada, and answered the question also that if that is the case, then with climate change we might have a significant problem with Lyme disease emerging in Canada. And we've repeated this with multiple modelling attempts. In terms of validating the model and detection and attribution, well, certainly over the 2 decades subsequent to the modelling work, then the tick populations have moved into southern Canada, and they have brought with them Lyme disease, the agents of Borrelia burgdorferi, resulting in going from almost 0 cases of endemic Lyme disease to thousands of cases, and it appears to be increasing exponentially right now. We've done a lot of field study looking to find out where ticks are in the environment, and those kind of thousands of studies have identified that the threshold of about 2,800 annual degree days above 0 appears to be correct. Below that, you don't find tick populations. Also, the spatial pattern of occurrence of tick populations, where we've seen the tick populations set up year on year, is a number of geographic scales dependent largely on temperature. As long as you have woodlands, then the major determinant is it above that 2,800 degree days. And we can see this at very fine scale as well. And we can actually see the emergence of the tick population if we study and go back year after year. Courtesy of as well as having the field study, we also had the a citizen science passive surveillance system, which we could use to estimate the occurrence of tick populations. But importantly, it was about a 25-year long data set that allowed us to look at how patterns had changed over time. And the first thing that showed was that, again, the warmer a location was, and the faster it has acquired tick population over time. And probably more importantly for attribution is that the emergence of those tick populations occurred when temperatures had risen above the threshold for the population survival, or so that or somewhat above that threshold. And importantly also for attribution, that period of increase in temperatures, which allowed the emergence of these tick populations, is the period for which we've got most confidence that it is associated with warming due to anthropogenic activity-driven climate change. And we can watch this from space and see how the temperatures are increasing and suitability for the ticks. So, so we've got emerging Lyme disease due to the northward range spread of this tick. We have looked at alternative explanations and the ecological explanations, and without any real evidence that they've contributed. So we think that this does provide evidence that recent emergence of Lyme disease was at least co-driven by recent warming associated with human-induced climate change. The impact is, in this case, on the vector-borne disease, is via long-term changes in climate and not impacts of extreme weather. Clearly, effects of climate change on human risk from vector-borne diseases can be due to range change, geographic range change, but also due to changes in the frequency and size of outbreaks that may be driven by changes in extreme weather events and so on. Tick-borne diseases don't show outbreaks as such because their life cycles are really too long. But either way, in general, what we're trying to do here is to attribute a change in risk to human health via effects of climate on other species. So there's a certain amount of uncertainty in that. And having taken that on board, the changes, long-term changes in spatiotemporal patterns, maybe those more easily attributed to climate change rather than increases and reductions in outbreaks. And that means that you have to have in place, and probably have to have had in place, long-term surveillance monitoring systems in order to detect and then attribute. So I'll stop there.
Thank you, Nick. Let me invite the other panelists to come join me up front, and Nick, you'll join us virtually. That's great. So now we have a good, robust, almost half an hour for Q&A. Actually, I want to start with a quick question for Rachel, if I may. You showed in your presentation a really interesting summary of the greater population extinctions for species in tropical versus temperate settings and freshwater settings versus terrestrial settings and marine. Do you expect that to hold up with larger sample sizes, and is there a biophysical or population biology basis for that kind of pattern that you're seeing?
So actually, quite often these statistics are biased by the number of observations. And with the higher risks in the tropical regions, is actually an area which is less studied compared to the temperate regions. So therefore, I think that's really real. If it was the other way around, I might not be so sure that it was. So I would expect that to continue, and very possibly the reason is that those ecosystems are very complex. And one thing that I didn't have time to talk about was some of the reasons why our models may have underestimated the impacts. And one of them is that they don't capture the interactions between the species. And the tropical ecosystems are highly biodiverse and very, very complicated, and might be more vulnerable to the losses of ecosystem functioning and so on.
Great, thank you. All right, so let's open it up to questions for any of the panelists. Yes, in the back.
I'm a lawyer.
Great, thanks.
My name is Anne-Marie Garty. I'm a lawyer, and it's a topic that concerns me a lot. And so I'm on your side. I'm telling you this up front because I'm going to ask a question from a defense attorney's perspective. But first, I'm going to say that I think Nick has the strongest case that there's no question about that somebody who's suffering from Lyme disease could sue under these circumstances, like potentially, because there's no question about the facts of that situation. So for Rachel and Jason, I want to ask a question that has to do with the correlation between population increase and climate and greenhouse gas emissions are identical. That curve is identical in both of those instances over a 200-year period. And so I think that that's a real weakness when you look at water withdrawals that could be be largely influenced by population and also biodiversity. Now, I know that Rachel used some instances like amphibians and some species that was on an island where there were no people, but that doesn't prove that it's not human impact on the environment that isn't causing the decrease. So can you address my concerns that how you remove the human factors, all of the impacts on the landscape, the water withdrawals, both subsurface, surface, and everything else in terms of what we do as a species to the entire Earth in terms of altering it, how that isn't the leading driver of the population decline of other species.
Okay, so first of all, the population declines of species in general. So there was a report recently that talked about a 75% loss of almost all monitored biodiversity. Those are not the impacts I was talking about there. The impacts that we have high confidence that we've attributed to climate change are not those 75% declines, but they are changes in ecosystems and local species extinctions and changes in phenology that have been directly attributed to climate change with high confidence. That is more than 90%. I'm not explaining to you, I'm not saying to you that all of the loss in global biodiversity that we've experienced is because of climate change. It's not. Okay, so the case would not be climate change is responsible for this 75%. The case would be climate change is responsible for those things that are mentioned in the IPCC report.
And what percentage of the 75% is that?
Well, I can't tell you that, but if you I think that the community could work with you to delve into more detail about specific groups of species or to try to pin that down in more detail. But there is abundant and very strong evidence that climate change has impacted ecosystems and species. In some cases it's very, very clear, for example, in the cases of coral reefs.
Jason, did you want to speak to that?
Sure. You don't. I think it's a hard thing to do, right? So I think you have to be very careful about the question that you're asking in terms of water resources. So are you talking about reservoir levels? If you're talking about reservoir levels and the impacts on those levels, both from inputs from changes in climate conditions versus withdrawals because of water use, for instance, in the Southwest, I think those things are contributing to both of those factors. But there's very good accounting about how much water is being used, how much water is being put in. And in terms of the inputs, how we're changing the precipitation cycle, how we're changing the delivery of precipitation, whether in the form of snow or precipitable water, those things are all, I think, well recognized, and we have strong underpinning theories for how those things are being impacted by climate change. So I think both can be true, and that's ultimately what's going on. You see this conversation in the context of fire as well. Is it changes in fire weather exclusively, or is it land use and land management? And those questions are all part of the story. So I think that's part of the disentangling that has to be done, but it's not something that's one or the other by any means.
Before we go to the next question, we're getting some comments online. If people could use the microphones, and also there's a volume control that dictates the volume from your microphone, that allows people online to hear both the questions and from the audience and the speakers. Thank you.
Great, thank you. Other questions in the room? Freddie?
So, Jason, you showed the IPCC figure, and you presented it as if it was a figure that provides a quantitative estimate, or as if it was a figure from a scientific study, whereas, of course, it's an IPCC very high level summary for policymaker figure, which does what the IPCC does, which is assessing the underlying literature, and that's what comes out of it. But you presented it as if it was something very different, and I think that brings me to the question. And then compared it with quantitative estimate based on observations and models, and so it seems that it's even really hard within the climate science community to get what the IPCC does, what our assessment figures, and also the burning embers that Rachel showed. I think, in my view, I think they are probably really useful in courts because they provide a really thorough expert judgment of the underlying literature and then the interpretation of the literature. But it's not a quantitative estimate that you can, where you can give an exact number. But I think it's much stronger evidence because that's where we have very high levels of certainty. But you, and so I think the first question is to Jason. So you said it's a very crappy figure. And I mean, it's crappy because there's just not much literature to assess. That's why, I mean, you can't have high confidence if there's a single paper. And I think that's probably also where just the IPCC calibrated language is really misleading. And so I would like to, from all three of you, to have a comment on, in this field that is even much more diverse in terms of how you talk about what comes out of the research than maybe in sort of when you talk about just rainfall or a heat wave. So how can what are the things that we actually can within the community agree on and then defend that in a court? Sorry, that was a very winding question, but I hope that you can comment on that.
Good point, and sorry if I hit a nerve, you're right. These are summary figures, and this really gets to, I think, some of the things that Ben brought up about the consilience of evidence. So what those hexagons represent is assessment across multiple studies, and I shouldn't be glib in describing what the IPCC has to do, which is summarize a tremendous amount of information in digestible bits via figures or otherwise, and really characterize a wide range of studies and observations. And so that certainly is what's hiding back there, and I apologize if I represented that as a single study that was quantitative in its characterization. I think what they're trying to get at with their levels of confidence is the degree of consilience in these specific areas, in regions where they're assessing things like drought. how many different studies, how many different factors contribute to the sense that there are increasing trends, for instance, in aridity in these given regions. So it's an important point to make when presenting this kind of material, which is that in most cases, these aren't individual studies that have done probabilistic assessments or otherwise, but they're trying to go to assess the consilience across a lot of different variables, across a lot of different studies, and represent the preponderance of evidence suggesting things are going one way or the other. And so some of what I think you're getting at is a communications issue, right? So we have to think about how we represent these figures, and take me as a bad example of how not to do it today. And better ways of representing that, and then also translating them in the context of court discussions, because I'm sure that one of the things that you're getting at is, how can we represent that information more effectively in terms of what it actually is describing and saying about the detection and attribution of these events?
Over here, and then you.
Yeah, thank you. I have a question. I think this builds a bit on Freddie's point about the scale of evidence when we're talking about modeling and evaluating impacts. So I think like what we're seeing so far is that we often have, or usually we have much higher confidence about impacts at a higher scale, whether it's at a global or kind of higher regional scale, whereas in the context of litigation, we often need to get very specific. If they're specific plaintiffs, or I don't know, we're talking about a specific geographical area, specific ecosystem. And so I guess, I mean, we've seen, you know, different examples, whether it's a drought or Lyme disease or, you know, species disappearing. And I guess the question is, if you're thinking of, you know, how do you feel as scientists, like to what extent do you feel comfortable speaking at a more localized, specific level about this kind of evidence? You know, would you be comfortable going into court and saying that, you know, we have you know, all this evidence at a global, regional level about droughts or whatever the topic, and that shows that, you know, this local drought by this one person making a claim is also, it's, yeah, how do you feel about translating from kind of the global, regional to the smaller scales as it's often needed in litigation?
Yeah, so I think that's something that would have to be dealt with on a case-by-case basis. So, you know, for example, you know, in the Tyndall Centre, we conducted an assessment of 300,000 species globally, and we projected the risks of climate change to all of those species. And I often get interviewed by journalists, and they say, I want you to tell me 4 species. I want to put a picture of an elephant. And I try my best, and I say, no, this is a statistical result about global biodiversity. I cannot tell you without pulling out our model results for the elephant and then speaking to 20 elephant ecologists whether climate change is a risk to elephants. So as it happens, we have a PhD student whose entire PhD is on giraffes and climate change risks to giraffes, and she is looking at the whole food chain, what the giraffes feed on, what the other threats to giraffes are, to try to tease out the contribution for climate change. So I would not feel comfortable now automatically saying therefore locally da-da-da-da. The one exception might be coral reefs, because that is so overwhelmingly critical. And, you know, Antarctic and Antarctic regions as well, the evidence is very, very overwhelming for the impacts. Almost anything is likely to be affected locally. Otherwise, it's much more difficult. And I would actually like to point the question back to you. So you're in this room, all of the people legally who are in this room, I presume you're in this room because you care about climate change and want to see more action. Could there not be some kind of move to pull together large aggregate numbers of people who have been affected, and ecosystems affected by climate change in different parts of the world, into one single huge case, and then we would not face this problem?
Lots of questions about jurisdiction there, I suspect.
Well, within one country.
So I just want to make sure that before you answer those questions, did you want to weigh in, or did Nick want to weigh in?
Nick, do you want to weigh in? You haven't had a chance to talk.
Trying to get myself on mute. I just, I'm the attribution from my perspective has been a kind of like almost an epidemiological process. Is it consistent with? Obviously, these are observational studies. All of them are observational. There's no experiment. We haven't got a control site of which we've cooled part of Canada again in order to see if we can drive the ticks out. That and inevitably, in general, in kind of that kind of observational study is a less strong than experimental ones, and what we have here is consilience, essentially, in the studies, and we've got a wide range of studies that have come together to give the support to the idea that climate change, and anthropogenic climate change, has been responsible for the spread of the tick. But it's really quite idiosyncratic, and sort of at the back of my mind is, I think, was the first question. Oh well, someone who gets Lyme disease could have a case in Canada that actually it was caused by climate change and those who've been responsible for climate change, but what is I have to bear in mind that all of these studies have been on the basis, they've not been put in place in order to attribute to climate change. They've been all for legal purpose. They're there for public health purpose, to guide our actions and activities. So I'm somewhat disappointed not to be there to carry on the discussion about what is needed legally in terms of what is deemed sufficient evidence, and that would give us a lot of starting point for our own discussions, and perhaps additional work.
So, thank you, Nick. A lot of hands shot up, and I just want to make sure I treat them in some kind of semblance of order. You had your hand up, and I want to go then to Sabrina in the back, and Chris, and perhaps Ben if we have time. So let's keep going.
Thanks. I had a hopefully somewhat quick question, just your thoughts maybe for Jason and for Rachel. A lot of reference to the IPCC, both in the talks and in some of the questions here, and other synthesis reports presumably as well. They are synthesis reports, meaning they're backward-looking by nature. They're seeking to synthesize an existing literature. We are at a place where some hazards or impacts, we are still seeing very rapid evolution of the scientific evidence. I'm sitting next to Marshall, who has done a ton of work on wildfire smoke in the past 5 years, very little of which is likely represented in the IPCC, and yet is a massive climate hazard, at least for those of us living in certain places. And so, do you see a trade-off between the reliance on consilience and the important value of consilience and synthesis in bringing scientific evidence, but the trade-off potentially between that and representing super important climate hazards that are in some ways at the sort of forefront of a rapidly evolving evidence base that might not be represented by the IPCC?
Yeah, so this is something actually that at UEA we've done quite a lot of thinking about. So we had a workshop last year at UEA on the future of the IPCC between a number of former authors and stakeholders. One of the points that we discussed was this problem of the fact that the reports come out every 7 years and that things like this emerge. I mean, you'll notice the new evidence that I showed in my talk was the wildfire. That's the thing that really stuck out to me as the big thing that had changed since AR6. So basically, there have been some efforts to create some novel ways to try to produce platforms. So we have one at the Tyndall Centre called Science Brief. So, for example, there is one on fire. So Corinne Mukwere and Matt Jones at the Tyndall Centre have created this place online where those working on wildfire can discuss publications and try, as it were, to do a mini assessment of the literature, a place where people can go and try to get the latest information, even though it's not in the IPCC yet. Just while I have the floor, I did think of a further answer to the gentleman over there about individual species. So, what in the IPCC, you noticed I said that 4,000, that there are 4,000 species that were specifically looked at. Half of them they did manage to attribute it to climate change. Yeah.
Sabrina.
I don't know who this question is for. Maybe it's for the room. I think we have a bit of a problem about, so I'm a sociologist and a filmmaker, so I think that the social change in which courts make decisions are as important as the legal and scientific processes going on inside the courts. And, you know, as you mentioned, Rachel, you have these journalists asking you to specify because the general public, which there isn't really a general public, but publics want to, they're thinking from a narcissistic point of view, right? They want to think about what's affecting them. And so if we want to generate concern amongst these publics that then can support judicial decision-making to address climate change, we need to help them understand how, I think, this is what I think, we need to help them understand how this science relates specifically to them. So as scientists are speaking in aggregates, or in large statistical analyses, it's very hard to make that leap. And so maybe this question is more for the legal experts in the room. How do we do that legally? What are the kinds of cases that, you know, especially, and my research shows that arguments around health and climate are actually particularly important, poignant, and compelling in the court. So, like, how can we do that in the case of Lyme disease? What is a kind of case where we can represent that as, maybe it's not viable right now, but viable in the near future, that we can inspire plaintiffs to be bringing these cases that are somewhat, I don't know, possible. So yeah, I don't know, maybe this is a question for discussion over dinner or whatever, but I think as a community, we have some work to do around meeting different needs of creating the change necessary to make all of this work. Sorry if that was just a comment.
Can you just clarify that comment? Because is what you're saying that the public's opinion is necessary in the context of these legal discussions to motivate cases brought to the courts? Is that the mechanism that you're suggesting is important?
I think that's one of the mechanisms, but I also think as much as judges are independent thinkers and deciders, they're still affected by societal norms.
They're members of the public.
They are members
as our
of
juries.
the public.
Right.
Yes, of course they are, and we see that in every kind of court decision, that the social change going on outside of the court is going to affect the decisions made inside the court. And, you know, it depends on the issue, which is more, which comes first, but I might argue that social change comes first and the courts often follow. So we need to be able to individualize these kinds of issues well enough to compel people in the public to, you know, get involved, believe, whatever.
So Sabrina, thank you for planting that conversation. I think we can take that further offline from this particular panel, but a lot of rich fodder in terms of the communication and public dimensions of this. I want to turn to Chris. I also want to check and see if we have questions online that we should take before we totally close this section out. So, Chris.
Rachel, I really appreciate you bringing up the burning embers. So first, a question to the lawyers in the room. How many of you know what the burning embers are? Not bad, but there's a lot of education that needs to be done on the burning embers. And Rachel just showed a small fraction. If you go to the Working Group 2 report, there's a 2-page spread on burning embers from the last report. I would say that 85% of the comments we received on those figures was, why are there no figures for my region, for my issue of concern? And there's 6 of them for health. There's 1 of them on Lyme disease. And so there are a number of sectors that are trying to do this much more specifically. And Rachel would be the best person to ask. I'm also willing to answer questions about the burning embers. We've worked on them for a long time, but might be an interesting approach going forward for some legal questions.
Thank you, Chris. And there's also one for Australia, if we have any Australians here.
Let me go online if I can, Dennis, and then we can come back if we have time for additional questions. So online, what do we have?
So we have one question at the intersection of science and law that will work with this panel and then tee us up for the next as well. So this is a broad question for the panel. With the growing sophistication of climate attribution science, do you anticipate this science fueling new cases and the emergence of new cases, especially under constitutional right to healthy environment or right to nature frameworks that hold specific parties legally accountable for the decline of particular species, or in the case of Nick's presentation, the rise of specific species and impacts to ecosystems.
I'm sorry, I couldn't understand the question. Would you mind repeating it?
Simplifying this question a little bit, how do you see the science in how do you see the work in attributing ecosystem impacts of climate change impacting legal processes and legal decisions going forward? Have you seen that start to happen, and to what extent do you anticipate developments in the science to impact developments in the course?
Okay, it's not something I really know a great deal about, but what I would say is I expect there to be more and more overwhelming evidence of the effects of climate change on species, and more evidence of the importance of ecosystem services in underpinning the economy and therefore the damages to human society. So I think there will be more and more evidence there for people to use to make legal cases. Now, how exactly those legal cases would come out, I don't know, but given that obviously each nation has its own legal system, possibly a national level, personally, I don't understand why a nation wouldn't want to some body in a nation wouldn't sue another body in a nation for the impacts of climate change in that nation.
Let me answer that question by saying I don't know. But I do think in the context of the social change component, I'm old enough to remember that communication around extreme events not too long ago was something akin to saying we can't attribute any single event to climate change. And obviously, with the work that's been done in this space, that's changed significantly over the last decade. And in terms of how that informs social change and the thinking in the public's mind about events as they're occurring and what we can attribute to them, I think that has to have an impact in multiple spaces. And it's not only is it happening more, but it's happening faster. That's a lot of work that needs to be done to attribute individual events, but we're able to communicate sooner and sooner with regard to our assessment of specific events and what kind of climate change fingerprints might actually exist in them. And so I don't know what impact that has. I think it's a question for sociologists, but it's definitely been a change in the conversation around this in the last decade.
And we're going to come back to this question in a variety of ways over the subsequent panels, because this is exactly kind of the sweet spot of the purpose of bringing scientists and folks in the legal scholar and practitioner community together to think about how this informs our scientific work can better inform litigation and draw upon attribution science. So we'll come back to this, no doubt.
And we also have a question from Joyce on the screen behind you.
She's got her hand up.
Okay, let's take it. Joyce, we can go over a little bit into the break.
So before the break, and I'll be quick and I won't put my video on if you don't mind, but this question goes to Rachel. So Rachel, you I think it's slightly tied to the question that Christy asked, or the comment that Christy made around about the burning embers, and it's the question that to me the burning embers is very temperature dependent, like the risks assessment of risks, very temperature dependent. So you're looking at impacts in the future, but then it doesn't at all look at issues of vulnerability and exposure, trends of vulnerability and exposure going forward, in the future, how that will change. It doesn't, for example, discuss issues of overshoot, what would be the dynamics of going beyond, say, a 2 degree, what would that mean for impacts? And I think the other thing as well is that, for sure for impacts, even if we bring the temperature down, it will be a different world for the impacts. So if we lose people, for example, if people die from heat waves or other events, or if we lose some species or they get extinct, even if we bring the temperature down, that will be a different world. We can bring that back. So maybe in the physical system, things might come back, but in the impacts world, things will be completely different. So there's no reversibility in the side. I think going forward, sorry, I'm just going to finish. So I think burning embers, if we go in the next assessment, and also talking about impacts and looking at the future, we should look at a more broadly way of trying to understand how things will change in the future. What's your comment on that?
I just want to make sure we give people time for the break, so I'm going to ask if any of the panelists have a very short response to this, and I see a two-finger intervention here, so I'll allow that to happen too, and then we'll break.
Okay, so in short, we had the aspiration to create embers for different socioeconomic pathways going forward, which have different levels of future vulnerability. The literature didn't support that, so we didn't. That means the embers essentially averaged across those pathways. Secondly, I'm a member of an EU project called Provide, which looks at the reversibility under overshoot, and we just published a paper called Overconfidence in Overshoot in Nature, and we'll be publishing more, and this basically shows which of the impacts might be reversible and which are not. Ecosystems and biodiversity are not reversible. It may be very, very difficult to bring temperatures down anyway. Almost all of the scenarios in which temperatures come down rely on a huge amount of carbon dioxide removal, and that technology is not proven, and if done at scale, it would have extremely negative impacts for agriculture and ecosystems.
Chris, last word.
Joyce, the health burning embers do take adaptation into account. They're the only embers that do.
Okay, with that, I want to thank our panelists. Please join me in thanking them, and enjoy a short break.
Bye, Nick. Thanks.
Well done.
Thank you.
Sorry how to jump through your slides. I was going to ask you to say what you did.
Meetings are on 12 minutes. I think it was under 12 minutes.
But was there flagging that?
Yeah, they were flagging.
I'm sorry.
Yeah, no, it's fine, it's fine. This looks like something I can plug it into.
Yeah, yeah. I'm glad you did that.
That's it? I think that's the unit. Yes, we have it. Yes, hold on 1 second. Now, Bradley, how did you get this screen to work? Tap the screen. This is you? I think here. Yeah, I think So this is, that's you, and then one other person, Raphael. Okay. Thanks. You also have a PowerPoint? I've got a video. I just need to. Video.
Oh, you said it's just a link, right?
Yeah.
Oh, okay, hold on, get
Elliot seemed like there's something
Oh, wait, this is here over here. Oh, I don't know who did watch this. It's from. I have no idea.
And the disc cup
Good to meet you in person.
Yeah, you did. Thanks for everything.
Oh, great thought was it? Somebody closed it. I don't know why. I remember seeing that as well. So when you
The plastic was. The plastic was something really.
Oh, wonderful, yes, yes, thank
Hi, good to, yeah, you too. Question. How long?
I think 15 minutes.
15 minutes. Okay, great. Okay. Okay.
My colleague, our co-executive.
This on full screen. Yeah. I guess the song, okay, one side, it should be. I have to very quickly. Okay. Will you help if I just... I'm the first speaker, so yeah, if you can just have it on one. I'm going to have it. Thank you.
You ready? So we're going to get started in a couple minutes.
The only thing is we can't see the slides.
Okay. Is Andrea going first? Ruben's going first? Okay. Okay, so in the interest of closing this thing on time, even though we're starting a little bit late, and even though people seem to still be outside, we're gonna get started, and people will make their way in as they realize that the party is happening again. Okay, so it is my pleasure to introduce our next moderator, Maria Antonia Tigre. Maria Antonia is my colleague at the Stevens Center for Climate Change Law, where she directs our global climate litigation project. She's a well-recognized expert on global climate litigation in the Global South, and in the ongoing international proceedings at the ICJ, the Inter-American Court, and other international human rights tribunals. It's a great pleasure that I have to work with her every day, and so with that, I'll turn it over to Maria Antonia to lead us through the final panel. Thank you.
Thanks. Good afternoon, everyone. I know that we're all a little tired, but I'm very excited to moderate this panel. We have amazing speakers. So it's really an honor to welcome you to this panel on legal and policy implications, fundamental rights and government obligations. This section really brings together an extraordinary group of speakers whose work lies at the intersection of science, law, and human rights. We're shifting gears a little bit, but very well connected to the sessions before. So obviously, as climate change increasingly threatens fundamental rights and government obligations, courts are really starting to grapple with the challenges of holding states accountable while navigating complex legal and scientific questions. So that's why we're all here. And the Sabin Center has, as you all know, a database on climate change litigation, which now accounts in the global piece for almost 1,000 cases and 1,900 cases in the U.S. database. So it's a lot of cases, and a highly visible category of cases is case related to human rights, fundamental rights. So this panel focuses on the role of attribution research and legal actions involving the protection of fundamental rights and government obligations, and we'll discuss sort of what are the key examples of rights-based litigations and legal proceedings. How does attribution science inform assessments of threats to human rights and constitutional rights, and some other aspects as well. So it's a pleasure to introduce you to our speakers. First, we'll hear from Pooven Woodley, who is an international human rights and environmental lawyer, and previously the executive director of Natural Justice. He's a lawyer for communities and the environment, and also the co-founder of Earthrise Collective, and on the boards of 350.org, Digital Democracy Institute of Natural Law, and on the ICCA Consortium Council. Then we'll hear from Andrea Rogers, who's the Deputy Director of the U.S. Strategy for Our Children's Trust, and since 2010, she has been litigating climate change cases against governments, including many cases that were mentioned here in the U.S. and advising some in Canada as well. Then we'll hear from Dennis van Berkel, and Dennis, if you can also come and sit here, as the legal counsel at Agenda Foundation. Yeah, I'm just inviting the speakers to stay here because I think it will be more efficient because you're all scattered throughout the room. So he's the strategic advisor at Climate Litigation Network. He's also the founder of Climate Litigation Network and has supported several climate cases around the world, particularly in relation to insufficient emission reduction targets, and he'll talk about some of those. And then we'll hear from Rafaela Santos Martins da Rosa, who's a federal judge in Porto Alegre, Brazil, and a visiting scholar at UC Berkeley Law. So we'll start to move in.
Thank you so much, and thanks for having me here. I think I definitely know why I've been invited and why I'm here. In the last 6 months, this is actually the third gathering I've been to with lawyers and scientists. A few months ago, I was deep in the Ecuadorian Amazon. Lawyers, scientists, and journalists and so on that were there as well. About a month and a half ago, I was crossing the Atlantic with some scientists, and here I am. It's my third gathering. So it's really encouraging knowing that lawyers and scientists are finally working and speaking with each other. But I think I'm here as well to speak to some of the missing pieces. I think when we speak about attribution, science, and the law, sometimes we don't bring in the intersecting crises, human rights and the environment, and how you can't separate them. Looking at indigenous people's rights, but also the issue of justice and equality. Because as we know, in terms of attribution, impacts are very different to different people depending on who you are on the planet. And if we present the science in a way that it affects everyone in whatever way, then we're not doing ourselves justice. The other part I'd like to bring in is the fact that, there's a massive focus on science, but very little attention on ancient wisdom, and specifically indigenous wisdom. It's still very much in the sidelines. Indigenous people get invited to COPs and other conferences, as we know. Part of it is the show, part of it is, okay, let's see what they have to say. But the science of indigenous people is not taken seriously at all. But what I want to show today is how powerful it is when you bring those two worlds together, because they can't be separated as well. And what we learn, both based on the climate science, the IPCC reports, and indigenous wisdom, is that we're in a very particular time on the planet, as we all know. It's so clear, yet we're being led in a certain direction, in a certain trajectory, which we can't find our ways out of. And so part of what I want to show is that it is possible, and there are ways for us to create our own pathway outside of the mess and the crises that we're in. I want to start by just painting a very quick picture, especially for the scientists in the room, in terms of where we are, human rights and environment and the interconnectedness. 1948, the Declaration of Human Rights, and since then we've had thousands and thousands of cases around human rights. Over the last couple of decades, we've seen more and more cases around rights of nature. We've seen it in many countries, New Zealand, India, Pakistan, the US, and so on. We're also seeing many climate litigation cases that you've heard already. Juliana, you heard earlier, you may hear about Agenda just now. The Ligari case in Pakistan, Torres Strait Islander complaint to the UN Human Rights Council, looking at the failure of governments to protect human rights based on what's happening on the planet, the Chevron versus Ecuador case. So there's many cases, on the rights of nature. More and more there's cases connecting human rights and the environment. The Futures case in Colombia was one of the early ones where, it was argued that in order to protect the jungle, the Amazon, you have to protect the people that are protecting it. You can't separate the people from other parts of nature. And there have been a series of cases now that are starting to bring those together. So you have human rights and the environment cases that are coming. The next, let's say, frontier, so many of us are involved in pushing the legal boundaries even further. So some of you may have heard the Sariaku people in the Ecuadorian Amazon have been pushing for the recognition of, they call it Kausak Sacha, which is a living forest. The idea that beyond the things you see physically, like the rivers and the jungle, there are spirits in the forest that they are very deeply connected to, and their ancestors are connected to. And you have to recognize that even though you can't see what's there, but they can feel it. And so that's the next push, let's say, in terms of taking this forward. In South Africa, Table Mountain, we've started a similar process where we're looking at the recognition of the mountain as a living being. Now, what this does is it starts to shift the way we see things, the way we experience things, and the way we perceive things. So it's really important on the legal front that we're pushing in that direction, but that starts to shift, everything else that follows. I don't have a PowerPoint presentation, but what I am going to show you is a trailer from a documentary about a case that I'll speak about just now to bring up some of these points.
The blasting was something really scaring everybody in the community. We were sleepless.
Shell is going to begin oil and gas exploration on the wild coast. It has people furious.
Amambondo, as people, have always been fighting to protect their land.
Shell must know right now that we are ready to fight.
Human rights do not belong to the state, they belong to the people. That's why when the government doesn't listen to us, we take the government to court.
Communities are entitled as a matter of law to contribute to a discussion about their own development.
There was no consultation to the people at all.
We're speaking for the land which does not have a voice.
We have one of the most beautiful pieces of land.
To me, it's my identity. I know myself through this land.
There's no way you separate us with the land and the ocean.
What is often missed in these sorts of discussions is the economic benefit.
We are up against government and Shell, which is a big corporate with very deep pockets. We don't want Shell to explore our ocean, that's all.
If we don't act now, it's going to be too late.
Dealing with the minister who has put his colors in the mast of Shell.
Humanity as a whole have to be asking ourselves, do we really want to carry on with these kinds of activities?
It's not saving every plankton.
We can't just assume that the absence of evidence means the absence of impact. If that means infringing on constitutional rights, then we must stop you.
This is the biggest struggle of our lives.
South Africa, stand for your life!
So just to briefly speak about this case, I was actually in Glasgow at the climate conference, and Agenda was running a workshop called How to Beat Shell. I didn't attend the workshop, unfortunately, but we did beat Shell. A couple of things, and they've appealed it many times, even to our constitutional court, and we beat them through the appeals. We took the usual arguments. So the first case, bringing an urgent interdict, we didn't have the climate science to back us up. There wasn't time. And we lost the first case because the judge said, A, we don't have enough evidence to show harm, and B, that Shell would lose a lot of money. Those were literally the two things. Anyway, in the second case, we were able to bring the climate science, the scientists, the marine biologists, and so on. But the other part of it was, bringing the indigenous wisdom from along the coastline. It was a 6,000 square kilometer block that they want to do oil and gas drilling. And one of the arguments we took to court was that the ancestors of the communities living there live in the ocean. And if you blast the ocean non-stop for 8 months, you would disturb the ancestors. And also argued that they connected to the land and the ocean and the cultural arguments based on our constitution. The Shell lawyers laughed at us. The judges took it really seriously. And through that case, bringing the science and the indigenous wisdom together was very powerful, that Shell wasn't prepared for and couldn't, in the end, argue against. So several cases, including the East Africa oil pipeline case, the Okavango Delta case, where oil and gas and other drilling is happening, what we found is, looking at fossil fuels, greenhouse gas emissions, and charting the climate change and the impacts is crucial, and that we have to keep doing that within these cases. Looking at, someone raised earlier, the local impacts of climate, biodiversity loss, looking at sea levels and extreme weather conditions in the particular areas, and the attribution around that becomes important. But also the cumulative impact analysis, taking the local and showing the global picture makes it very, very compelling. And the last point around ecosystems in terms of the economic, but also more importantly, the social and cultural dimensions of people and how they are connected. I'll share probably in the discussion, just some of the other lessons we've learned through some of these cases. But just to say that I do think it's really important bringing the different worlds together and starting to recognize as scientists, as lawyers, that there's a lot of knowledge systems out there, and the more we bring into the courtroom, the more powerful it is. Thank you.
Really help with tech.
I don't know how to turn on the next slide. I'm not going to pretend. But it's a pleasure to join everybody, and thanks for sticking around. I know it kind of sucks. The last group is lawyers, so, I'm not sure about the planning on that. But we really appreciate to be here. As was introduced, I'm with Our Children's Trust. We're a nonprofit law firm, and we exclusively represent young people. I do, yep. It's called Rogers. That way, it's at the top. Yep. Thank you, thank you. No. Oh, you're going to do it? Yeah. Share. There? This one? Yeah. View slideshow. And how do I move it forward? Just with the button? Okay, great. So there's where we are. Here's some of our clients. We exclusively represent young people in constitutional climate change cases against governments. We have a very narrow lane in which we're working. We've been doing this work since we were founded in 2010. Our mission is to secure young people's fundamental rights to a safe climate system. I'm going to focus a little bit on our work in the United States. We have incredible experts who will be able to speak about their work in other countries, but I'll be focusing exclusively on the United States, where things get a little tricky for causation and redressability. I'm also going to pivot a little bit to try to answer some of the questions that we've heard today, some of the legal questions that came up. So I'll try to sprinkle that in. Of course, I'm a lawyer. I have way too much content to share. I was hoping to talk to you about Montana and Hawaii, both of which we obtained incredible results for young people in both states. Both states now have a fundamental right to a safe climate, which is protected in their black letter law, which is incredible. So 2 states down, 48 to go. But I think I'll probably focus on Montana because that really touches on a lot of the legal issues that has come up in some of our discussions today. Here are our incredible plaintiffs and where they lived in Montana. A huge part of our work is elevating the stories of our young plaintiffs. It's vital for courts to understand how young people are experiencing climate change, not from papers, not from studies, but from the youth themselves. So they take it upon themselves to testify in court and really share their experiences as to what's it like growing up in a destabilized climate system. What does it mean to miss school for 2 weeks because of wildfire? What does it mean to lose your home because of flooding? They really can best articulate those stories, and so our goal is getting those stories heard in a court of law. Here's one of our plaintiffs, Olivia. She was testifying at trial. So our Montana case was filed. It actually went to trial fairly quickly. It was filed a few years ago, went to trial last summer. And it was really the first time that young people were able to access their courts. So we've heard a lot about causation and attribution. The hardest part in the U.S. is actually opening the courtroom door and getting inside. That is the hardest thing. That is what we have been litigating literally for 15 years, is just getting inside the courtroom to be able to present the evidence. That's what we were able to do in Montana last summer. Remarkably, the case was live streamed, and there's an incredible website where you could look at all of the testimony. So if you want to see what it's like to be a scientist testifying in court, you can watch it live there so you can see what that looks like. And here I just wanted to, I know there's a lot of text and my colleagues make fun of me for texty slides, but after seeing the complex graphics on some of the earlier presentations, I don't feel that bad anymore. But I just wanted to sort of you to see the kind of impacts that resonated with not only the judge, but this case was recently affirmed by the Montana Supreme Court on December 18th. So several judges on that court recognized the validity of these impacts as well. So these are the kind of impacts that children are experiencing that courts recognize as valid and viable. Now, the one thing I wanted to point out with injury in legal cases, it's really important how you frame the injury, because how the injury is framed affects how you have to prove liability, which then affects what can the court do to relieve the injury, right? So oftentimes you think of the injury as climate change. Courts generally don't buy into that. It's too abstract. They see it as everybody's affected by climate change. It's a concept, not an injury. So it's really important to show what the injuries are, what the plaintiffs are experiencing. Losing their home, feeling constrained that they don't want to have children because of what's going to happen in the future, losing their ability to have cultural ceremonies because there's fire bans on the reservation. Those kinds of personal injuries are injuries to their constitutional rights. That's something that the court can get their heads around, how these young people are injured. And again, it's through their own words. Then here's where the experts come in. These are our incredible expert witnesses, all of whom prepared written expert reports, which is a summary of the state of the science. There's quotes to individual papers, there's IPCC materials in there. It really is an incredible piece of work because it needs to be short and digestible. All of these experts come with a variety of different expertise, including indigenous expert. Bringing the indigenous expertise into the courtroom is particularly important. We had pediatricians, glaciologists, energy experts, psychologists, all of whom bring these stories. And what they do is they say, here's the state of the climate science, and this is why the injuries that the plaintiffs are experiencing. So the plaintiff who couldn't get home because the flood washed away the only bridge, this is how that's tied to climate change. So our cases are against government. So governments, governments aren't necessarily the primary polluter, right? They're not the ones who are generally operating the facilities that pollute. They do to some extent, of course. But what we're challenging is their conduct, which authorize and locks in the use of fossil fuels. So they have several policies that do that, whether it's granting permits, issuing a law that says when we issue a permit, we have to pretend climate change doesn't exist. That was a law that they had on the books that we challenged as unconstitutional. So our experts are the ones who take that science and digest it so you'll see some of it to the audience. Some of it will have attribution science in that. Some of the scientists will talk a little bit about that, tying certain events. But it's not it's more big picture because again, we're not trying to prove climate change is the injury. We're trying to prove the constitutional violation, so what these particular plaintiffs are experiencing. So the framing of that is really important. And also it's really important, the expert testimony, to show that, look, we can do something about this. So climate change cases in the United States have been filed for over 40 years, most of which have been dead ends because there's been a variety of different excuses for courts to get action, to take any kind of action. One of the primary ones is this problem is just too big. It's too big for us. We're just a little state in Montana. Sure, our emissions are larger than the country of Colombia and other places, but it's just us. We shouldn't have to be doing something about that. And so I wanted to pull out a few of the facts from our expert that the court then adopted. So these are findings of fact that were upheld by the state Supreme Court, really rejecting that notion that states and individual governments don't have a responsibility to address their own impacts. And this is huge because, again, some of the cases, we've lost many cases in our time. We're finally starting to win our cases. And many of the challenges that we experience is that whole drop in the bucket argument, or it's happening somewhere else. But we can't control this. But we really have very careful evidence through our experts talking about how the state does control the fossil fuel energy system along the way, and how that impacts the environment in the state of Montana and the plaintiffs who live there. And I love, when this court says the state does not have a free pass to pollute the Montana environment just because the rest of the world insists on doing so. That's huge. I can't tell you how many cases have been unsuccessful because they'll say, well, the other guy's doing it, so it's not our problem. Now, climate change is inherently a multi-causal problem, right? There's lots of contributors. That shouldn't be a death knell under the law. The law is very familiar with multi-causes in a variety of different contexts, dating back thousands of years. And but courts in the climate change context have really struggled with that. So that's why it's so important to be very clear in the chain of causation, very clear of what your injury is. How does the government control what's happening? How does the government cause what's happening? How does the government contribute to what's happening? We're not going to say that Montana is responsible for all of global climate change, right? We can't prove that case. But we can prove that climate change is happening now. The plaintiffs are experiencing injuries at present levels of warming. So right now, we're in the danger zone, right? Injury is happening now. The constitutional breach is happening now. Now, we can also show what's going to happen in the future through projections, and those are considered future injuries, and those are viable in the court. You just have to show that future injuries are certainly impending. And I think some of the scientists here can probably meet that standard, certainly impending, right? That's what you have to show legally to show future injury. Now, why future injury is important? Future injury is important because the requested relief that we're asking for, we're not asking for money damages, which is for past conduct, so stuff that happened years ago. We're asking for declaratory relief. We want the court to say what the government is doing is wrong and needs to stop. And if they stop it, this is the injury that they will be reducing. Not eliminating entirely, but reducing. So here again, this is the wordy slide, but this is really, really important. Because again, these were facts that were taken from the expert testimony and then incorporated into the findings of fact and conclusions of law to show that we're in the danger zone now. So if you're authorizing additional emissions, you're making it worse. So every ton matters was a theme of our trial that several of our experts were able to touch upon in different ways depending on their area of expertise. But this was important because we were able to show the breach is happening now, and if the government continues to do what it has been doing, the breach is going to get worse. And why that's important to show is it means there's something the court can do about it. The court can tell the government to stop doing what you're doing. They're generally not going to tell you how to change course, but they can tell you that you need to stop. And all of our experts were able to testify, well, you need to stop emissions if we need to get to where we want to go, right? And then they'll testify, where do we want to go? We want to get to zero emissions, depending on what you're talking about. So they're able to say that, and so the court was able to grasp and make that link from injury to causation to a remedy. Here's just some more language talking about this multi-causal reality. Another challenge is that courts oftentimes, in the climate change context, largely say that you have to, solve the entire thing. You have to prove that everything is okay, and that's just not the redressability requirement, even in federal law. And that will be litigated coming up in the Supreme Court in a couple of different cases that have recently been granted cert. We're hopeful that that court will reiterate the fact that you don't have to do so very much. So I'm just going to leave it there. I've exceeded my time. As I said, I wanted to talk about the case in Hawaii. So hopefully there'll be questions about that because that case actually settled. The government decided to work with the kids and they agreed to achieve zero emissions in all state transportation systems by 2045. And the court has continuing jurisdiction throughout that time. And so if something goes wrong, we can go back to court to hold them accountable. But that's a story for another day. But again, the expert evidence in that case really led us to that result. So I will turn it over to my colleague. Thank you.
Do I now also need to do something to get it on Zoom, or? Yes. Okay. So I stop share. Then I go to Zoom. No?
Yeah.
Oh, sorry.
Go to the Zoom on top.
Oh,
Right
here.
there.
Okay, thanks.
Share.
Now I share. Are we there?
We're getting better at this.
Okay, great. Hi. Yeah, so thanks everyone for organizing the conference and for the fascinating presentations earlier today. And there were a lot of questions asked by the scientists, and I was like, I want to answer that question. But then the question was for the panel. So if there's more, but maybe in this panel we can engage a bit on that. My presentation will not be on that particularly. It will be on two particular cases, and it's important. It's the cases that I'm going to comment on are very similar to the case that Andrea mentioned, and they're about the government's responsibility to basically reduce emissions more than they're currently doing. They're fundamental rights cases. They look towards the future. They don't look towards the past. They don't look to damage or who needs to pay for damage. But as I'll point out, they might serve as a basis for those future questions. I'm just a little bit of background why I'm, the background of me talking to these cases. I work for the Agenda Foundation, which was the organization in 2015, the first case in the Netherlands where a court concluded that there was a government obligation to reduce emissions more than they were doing based on fundamental rights. We founded the Climate Litigation Network and have been advising dozens of cases around the world. So the two cases, these two cases are two of the cases that I also advised on. So my experience basically comes from that. The first one is from the European Court of Human Rights in the Climate Seniors case against Switzerland. This is a case in Europe that comes on the back of a number of cases in the Netherlands, Belgium, Germany, France, where national courts had determined that there were these responsibilities of governments to reduce emissions. In Switzerland, they lost in all instances. And if you lost in every national instance, then you can go to this European Court on Human Rights saying my human rights are being violated. So this is a case that was filed in 2016. After our first win in 2015 in the Netherlands, and was decided in April 2024. The other one is way across the globe in South Korea, a very recent case before the South Korean Constitutional Court, which also concluded that in South Korea there is a constitutional obligation of the Korean government to reduce emissions beyond what they were currently doing. And I think that when it comes to sort of globally overall obligations with regards to how much the total emission reductions add up to, these are kind of, the two most probably advanced cases out there when it comes to the statement of the law. I will first mention my conclusion and what I won't discuss too much. The conclusion is that these courts have accepted that there are fundamental rights obligation for a state to do its fair share. And most of the signs that I'm going to discuss are going to be on this fair share question, to remain below 1.5 degrees. Attribution science hasn't played that much of a role in these cases. There was a role, I will comment on that briefly, and that this responsibility question was not so much a scientific causal connection as you might understand it, but what's more based, and that's also what Andrea if you looked at the excerpts that she showed, the very similar statements were made in these cases as well, and a more legal concept than scientific proof of causality, so to say. All right, so these just some main points. So I'm going to switch between these two cases, and to make it a little bit more easy for you to follow which of the two cases I'm referring to, I've added a symbol in the corner. This is the symbol of the South Korean Court, Constitutional Court. They determined that there is a right to a healthy environment, and that based on that right to a healthy environment, the state has an obligation to take the minimum protective measures that are appropriate and effective. What is important here is that there's a role of the court is not to determine what policy needs to be. That's for politics to do. But the role of the court can be that they say, well, there's a lower limit. There's really a limit below which you cannot go because the harm just becomes too bad. And that's what you see in this statement. With regards to how they went about addressing or deciding whether the climate policies were sufficient,
they said that the measures needed to be based on scientific facts and international standards. They gave in particular importance to the reports of the IPCC, and with regard to the international standards, they concluded that there needs to be, the state needs to do its fair share of staying below 1.5, and that it needed to act in line with this principle that is enshrined in the UN Climate Convention and the Paris Agreement, called Common but Differentiated Responsibilities and Respective Capabilities. In short, basically, it's not the same thing as fair share, but I'll just call it fair share for now. And moreover, that there also needs to be a framework for setting targets that is designed to prevent excessive burden from being shifted onto future generations. In other words, there need to be actual laws that set out a pathway of how much you're going to reduce over the entire time span until zero emissions. And you need to also argue and show how much cumulative emissions you are going to emit over the entire time span until zero emissions. That's your constitutional duty. The European Court of Human Rights actually ruled in very similar terms, but on an entirely different article, the right to private and family life. And based on that article, the European Court concluded that there's a duty to adopt measures that are capable of mitigating the existing and potentially irreversible effects of climate change, and that mitigation must be supplemented with adaptation. With regards to the emission reductions, also here they need to be in line with international commitments, so again the international norms, and based on scientific evidence, giving a lot of importance to the IPCC, and concluding from the international norms that the state needs to do its fair share to stay under 1.5. So you see these two courts at very different places in the world with a very different national constitutional system basically coming to the same conclusions. But the Court of Human Rights went a step further, and I'll go a little bit deeper into that later. But they said that there is a specific regulatory obligation, that targets must be laid down in this binding regulatory framework, which was also what the Korean Constitutional Court said, but also that they have to quantify a fair share budget. You can't just set a target and say, all right, this target is sufficient. No, you need to quantify what your fair share budget is in relation to the global budget. And that proved to be essential in that case. With regards to the individual responsibility of the state, why was the state actually responsible for the impacts of climate change? Well, similar findings as Andrea mentioned, the drop in the ocean argument just didn't fly, and the South Korean court, I know that the letters here are too small to read, but basically what they say is, if countries themselves say, well, I'm not going to act if others are not acting, then in the end, nobody will act. So you need to act yourself to create the confidence that others will act as well. So that's kind of like how they constructed this legal causality. With regards to the Korean court, they concluded that there was a violation for not having targets between 2031 and 2049. They did not conclude that the 2030 target was insufficient because there was no indisputable international consensus on what method that would be, or there were no calculations by done by domestic institution. And I think these two things were quite important and different in the European context. How many time do I have left? Just 1 minute. I'm halfway, guys. I should have known this. In the European court, how can you give 15 minutes to a lawyer?
I know. That's cruel.
Shouldn't we have a case against it? All right, I'm using my time the wrong way here.
We usually do.
So, what happened with regards to the 2030 target? The European Court did find that there was a violation because of the 2030 target, which was minus 50% compared to 1990, and they were on a trajectory towards zero in 2050. They did not find that sufficient. And why? Because the Swiss state did not quantify what it deemed to be its national carbon budget in relation to the global budget. Now, what was the difference between the two cases? In the Korean case, the Constitutional Court said, we don't know what exactly the one the one defined methodology is. That's not what the European Court did. The European Court said, well, we see we see that as a court, it is difficult for us to define a one fair share methodology. But we can ask the question. So that's what they did. The court asked the question to the Swiss government. It said, well, given that there is a global budget of about 400 gigatons left, how did you define your national share of that budget? And on the basis of what principles? And basically the case was won because the answers of the Swiss state were just fell short. They said, well, there's no one methodology, etc. There are other papers, it's all arbitrary. What the plaintiffs showed is that, well, if you actually follow this IPCC pathway towards zero, if you're a high-emitting country, you emit more over the entire course. So you're just taking up a much larger share of this remaining global budget. And this was a graph for illustrative purposes that was submitted in the case. What they also showed that even on the basis of an equal per capita emission basis, so if every single person gets an equal share of the budget, even then, based on the targets of Switzerland, their budget would be depleted by 2030, and that Switzerland took up twice the share of its population, basically on the basis of that target. So that's why, that's the basis on which the court came to the conclusion that there was a violation. Now, I ran out of time. I'm just going to still use one more minute and just go like this. So what about the future? What about the EU? Well, in the European Union, there's this incredibly important report by the European Scientific Advisory Board on Climate Change, instituted under the European Climate Law, which is such a national institution that the South Korean court referred to. And it looked at what should the target for 2040 be. First of all, they looked at how fast can we go down. Well, this is about the trajectory that they thought was feasible. And then separately, they looked at the carbon budget, divided it up in different terms, and basically they said, well, either you've already run out or it's very small. So in other words, there's a gap between what you can do and what your fair share is. And you need to compensate for that gap. You need to compensate for that gap by paying international finance. And that's my conclusion. That on the basis of what the European Court of Human Rights has said, if you look at the science, there's a case that there's a legal obligation on the European states now to actually start paying other countries for emission reductions because they already ran out their fair share. I had more to say, but I'll leave it at that. Thank you.
Let's look for the name. This one. This one? Yes, one. Yeah. Yeah, go ahead. Just share. Hello, everybody. So be a little more patient, but I will start it because I'm running time. Well, I'm grateful for the invitation, for the opportunity to learn from so many professionals that I personally admire, and for the space for someone who is part of the Brazilian judiciary, who is now deciding cases on climate disasters in Brazil, in the federal court of my home state, which was severely affected last year by a climate disaster, and who is also a researcher an author in this subject. And I also congratulate my fellow panelists, all brilliant in their presentations, and everyone in the audience, both in person and online. Can we go? Yeah. So I divided my presentation in 3 topics. The first one, and I will talk more briefly because my fellow panelists talk about much more about this. What the great advances in climate litigation in recent years reveal mainly about judicial rationality and about how we judges were able to receive scientific information and translate into legal categories and judicial orders that recognize duties with enforcement. The advances are special in duty to mitigate emissions, and I will explore the reasons I consider central for these cases are successful ones, how attribution science can continue to help in future cases involving government duties to mitigate. And in the second part, I want to reflect a little bit how we can incorporate the use of attribution science into the judiciary, and how we can relate the protection of the climate system, a safe climate system, with the legal duty to not cause harm. And I will explore the Brazilian example, how we worked on this concept in the 2 recent years to disseminate the concept of climate damage. And in the third part, and to conclude, it seems to me important to talk about, we have strong judicial precedents now in recognized government's duty to mitigate, but it's clear that we have such a gap in judicial decisions on legal duties to governments to promote adaptation, and also if governments could ask for private entities to be held accountable for helping to cover costs of adaptation measures. And I think this is an urgent field, and which attribution science will increasingly contribute. And in conclusion, I will make brief final considerations and a personal request for help from scientists. So, it's very clear that success in advances that have already and will occur in climate litigations necessarily depends on dialogue between science and all types of science and judges. Progress occurs when we are able to translate scientific evidence into legal mandates. But it's very important to realize that we judges are prepared to deliver and are expected to do so decisions based on constitutions, conventions, laws, principles, precedents. Everyone expects our decisions have stability and also coherence. So maybe judges will not be disruptive in trying to solve the problem of climate change, just as we are not in other areas. However, I believe that we have a great disruption possible. And this is the use of the legal tools that we already have to judge the merits of the climate cases that we receive. And this is we can simply do. Climate mitigation cases, wherever systemic ones, just Korean case or agenda, just analyzing a government's entire plan, standards, and intermediate targets to reduce emissions, or specific ones, deciding about just one project, one fossil fuel project, are the cases that have made most progress. We already have like a clear picture of government's mitigation duties. And this is true for both courts in the countries of the global north and in global south. And reading and studying all these decisions, I understand that this is occurring because the main legal tools were used by judges: fundamental rights, constitutional rights, and liability for climate damage. And I want to emphasize these legal concepts are not separated categories. On the contrary, they are connected. So, decisions recognize the duty to mitigate in a way to ensure protection of the climate system. A warming climate system violates human rights. The protection is only effective if science is respected, so emissions are urgently reduced. In reaching this rationality, they reinforce that human rights conventions or constitution are living things. And these judges really advanced on the interpretation of the meaning of progressive protection to include climate rights. And second, these judge decisions is very important. Understood that mitigation is directly related to reduce one global damage, which is the warming the climate system. This damage was understood as a very specific dimension of environmental harm, but it's not a type of damage that cannot be addressed in court decisions. In all cases, we consider successful one in mitigation. Judges were like planetary, even if they were ruling in their home courts. These judges may have given different names to this harm, warming the climate system: poor ecological damage, environmental damage resulting from emissions, dangerous climate damage, talking about future, But many decisions simply call environmental damage, but different names do not matter. These judges have really assimilated that the climate system is a totality, so emissions have no borders, all emissions matter, even if the government is a small emitter, each one must act in their fair share of responsibility. There is, in fact, only one global carbon budget. And since there is a global damage, judges realize that emissions that occur in other countries will always matter. Both emissions for products produced abroad to be consumed in the country where the decision is made, as well as emissions for products such as fuel extracted in a country or resulting from deforestation. Climate damage is not just transboundary, it's ontological planetary. So political decisions may talk about import and export emissions, but judges look at the science and realize how much this decision is an illusion for a damage that is global. Therefore, the judicial decisions that have advanced by imposing increasingly detailed concrete duties to mitigate on governments, each one on its own way, have really understood the causal and legal relationship between emissions, the damage that is currently warming, and the risk of reaching future climate damage, reaching tipping points and irreversible warming. The causality of these cases is essential, comes from attribution science, and it's more simple because it looks like a single step. I understand that this causality graph should be present in all climate mitigation cases, and I strive to explain in every class I give to my fellow Brazilian judges. And finally, in these cases, judges also understood that greenhouse gases are pollutants not because they directly affect people, they are not toxic, as say European Court. They are pollutants because they cause harmful heat in the climate system, including some parts such as the ocean. And the decision in the International Tribunal of the Law, SC, just reinforced that. And in these cases that we can call successful ones, they over barriers of standing, and Andrea talked about, and I understand that this is occurring for two main reasons. First, judges really understood that the warming of the climate system isn't the warming as a whole, so yes, in some way, humanity as a whole is affected. In jurisdictions where this specific requirement of standing as proving of current damage in personal harm or risk of harm, as is the case in Brazil, all groups, there is no such a requirement, so all groups or public prosecutors who defend the environment, who defend present and future generations can file mitigation case and have decisions on merits. And in procedural regimes that require damage to specific victims in order to process the cases. For me, it's important to highlight that judges in successful mitigations have understood that showing past or current personal damage, for example, to children and the elderly, has one main objective, and is not requesting compensations, reparations for this damage, but show that if mitigations occur in accordance with the pace of science, precisely these people, these groups, will certainly have reduced future damage. And I think where I believe attribution science could help them even more in future cases on mitigation against governments. I summarize here many key points that I think it's very important to the science prove in the next cases on mitigation. So, second part. And how can we make judges really understand the importance of using attribution science in their own decisions? One path taken in Brazil was to really disseminate the concept of climate damage as a damage to the climate system, but as a dimension of environmental damage and based on rules issued by the judiciary itself. I use the Brazilian example because I worked directly there over the last 2 years as an assistant judge in the National Council of Justice. 3 important pieces of information. Brazil is one. Brazil is one of the largest historic emitters of greenhouse gases. But 2, emissions in Brazil are mainly related to illegal deforestation and forest fires. So in addition to carbon majors, we have our major deforesters. And third, most of the Amazon rainforest is in Brazil, around 17% has been deforested. Scientists estimate if we go to 20 to 25, the Amazon will reach its own tipping point, and this will have obvious devastating consequences for the entire climate system. So we know that a fundamental contribution in Brazil mitigation is to attack the behaviors that generate our main emissions. However, our journey to integrate accountability for climate damage into Brazilian judiciary. First, it's essential to highlight that for Brazilian law, climate damage as a dimension of environmental damage is a constitutional damage. It's different. Liability for environmental damage in Brazil is a matter of public order. It's not just tort law, it's not a private law relationship, it's not only regulated by the civil code. So, what we do? In 2021, the National Council of Justice issued the Resolution 433 to guide federal and state judges when deciding on climate and environmental matters. The resolution provides that judges must consider, wherever deciding on environmental damage, the impact of the conduct on the climate system. Well, there is a duty to consider the global repercussion of an action that takes place in Brazil. And to help guide to decide and measure this impact, our working group created 2 judgment protocols, one in 2023 and another one last year, 2024. Our main focus was the most emitting behaviors in Brazil, forest fires and illegal deforestation. The first protocol guided judges to use satellite images as proof to decide environmental and climate damage. We explained the basic concepts about remote sensing, summarize all satellites, detail that are reliable. But the most important is the second protocol. The second protocol, we included a glossary of concepts. We explained that climate damage is a dimension of environmental damage, and wherever conducts cause the emissions or suppressions of carbon sinks is decided in cases, these conduits should be considered as having effect of global climate damage. We also include in the glossary of the protocol both the concepts of climate change attribution science and the concept of attribution science of emission source. We put together a step-by-step guide using a platform that estimates emissions from all Brazilian biomes, considered carbon stocks, and the decisions could apply monetary values determined by the protocol for each ton of carbon. And now we are witnessing in Brazil an explosion of cases involving climate damage from deforestation and forest fires. Federal government prosecutors and also the public minister are filing strategic cases against defendants who have committed deforestation or fires in large areas. Considering climate damage in the decisions greatly increase the amount involved, and because of that, judges can order preventive measures such as prohibiting receiving properties, block bank accounts to stop the harmful activity, and also to issue repayment in the final judgment. But what I consider the most important of this movement by the Brazilian judiciary was to better establish the concept of climate damage among Brazilian judges. Now, Brazilian judges have improved the understanding that emissions hit up the climate system, that this warming is caused by human action, is damage, of course, on a planetary scale, but that we can impose individual accountability. And the resolution and also the protocols determine educational activities for judges. We are holding many training courses on climate change law. Last year I gave courses to fellow judges from 8 different states in Brazil. We explain fundamental concepts of climate science and the branches of attribution science. And this year we will also work on the connection between attribution science and disaster law. My time is up. Okay. So just my personal request, because it's important. I have as you may know, in the last year, in May 2024, my home state, where I live and work, experienced the worst climate disaster in its own history. The flooding affected total area similar to the size of the United Kingdom. Many lives are lost and many people are still missing. In response, last August, the federal courts of the 4 regions created a special unit with 3 federal judges to decide cases involving the climate disaster, and I am honored to be one of the 3 judges who are in this special unit. Cases have already started to arrive. One of is already in this BASE, the Cyber Center database, demanding accountability from federal and local governments. But I really believe that new cases could also demand accountability from significant emitters. And I am compelling many studies such as this one, made by World Weather Attribution for the flood in my home space. And I would ask that you send me all the studies that you have produced or know about our climate disaster, because I really intend to use them in the decisions that I will make. Thank you.
All right. Thank you, everyone. This was an incredible panel. I'm sure everyone will have lots of questions. Maybe I'll ask the first one, and then we'll move on over to our audience. And hopefully that will give some of you the opportunity to talk a little bit about what you didn't have time to talk about. We talk a lot about mitigation cases here and some very successful decisions all over the world that have recognized the government's duty to mitigate. And as some of you mentioned, these were mostly related to, declaratory judgments. So how can we leverage these judgments to recognize climate damage? And I think Rafael talked a little bit about that, but maybe the others can discuss this as well. And how can scientists support these new cases that can come up on recognizing climate damages due to human rights violations?
Thanks so much, and thanks to the other panelists for brilliant presentations. I think the one very clear area, so the thing I didn't speak about was, it took many decades, but in 2022, a new human right was introduced, or a resolution passed at the General Assembly, called the right to a clean, healthy, and sustainable environment. This is really significant. It's a new human right, but what it does bring together people and the rest of nature, because the reality is we're not part of nature, we are nature itself. And we've written a lot about what it means, but we're also now starting to test that in courts, and I think that's one area in terms of a right to a healthy environment where scientists can really help from all different disciplines, to bring that interconnection and to push for government obligations, around that interconnectedness. The second thing I would say is, we won that case against Shell, but then realized there's 400 other oil and gas permits just in the African coastline that has been granted. So it's a massive endeavor. And part of the challenge is finding the right scientists to be part of many of the other cases that we're embarking upon. So connecting the dots is going to be really crucial, because with these cases, we have to be really strategic in finding the right people in the right time that are able to support communities, on these different aspects. So that would be my appeal. How do we strategically do this?
Yeah, I think that's right. The damages cases in our cases looking at, mitigation, they're very distinct in many ways, but there's also a lot of connectivity. Courts sort of move, they move very slowly, but they often can kind of move together in a variety of different contexts. So I think courts are starting to get comfortable with the concept of having climate science in their courthouse, and I think that will help in the context of the damages cases. And in terms of needs, it's really vital that litigators understand the best available science, It's really easy for us to read the IPCC summaries, but as, we had a great question or great statement earlier, that's not necessarily the cutting edge research that's going on. And so I think typically in courts, you really need a blend of that, particularly in US courts. The IPCC can sometimes not be helpful because it supports the notion that climate change is a global phenomenon. And so really it's the local and regional impacts that are most important because those are the stories that the young people are talking about. They're generally talking about what they experience in their own backyards. So I think sharing that and being willing to educate, it's a lot of scientists don't like to be experts. One of our experts in the Hawaii case, he had a horrible experience being deposed in an earlier case, and so it was really hard to convince him. And we made it very clear that we are better lawyers than we dealt with before, and would defend him more strongly. So, because that's a tough experience to be deposed. It's hard to sign up for that. But it's worth it. I think courts are playing an integral role in addressing the climate crisis. We are not going to solve this by the political branches alone. So I think even if that requires scientists to get out of their comfort zone and communicating their science in a court of law, it's just vital. We cannot win these cases without presenting courts with the best available science. Full stop. We are totally dependent on the scientists and the work that's happening and the work being communicated to us. And it's also a way for us to help change the narrative because testifying in an open court is an incredible way to get your message out. Not that everybody doesn't read science in nature, but testifying in open court really is an effective way to communicate that in a way that people can understand given the audience. So that's really our needs.
Yeah, so the question you asked is how can you use these fundamental rights cases for the damage? And I think that the damage part is in many aspects more complicated. But let me just give a couple of thoughts, and a lot of things will have to be tried, right, that haven't been tried, and these are just thoughts, but I think it's important to distinguish between corporations and states here. The state responsibility that has been established under these fundamental rights cases is that they need to do what is A, necessary to stay under 1.5, and B, they need to take adaptation measures. So, all right, so if this is their fundamental rights obligation, and it's important to understand that these are fundamental rights of the people within the jurisdictions, which are often, unfortunately, not the people that are most affected, right? These are global north countries, litigations that I'm mostly talking about. So it's about the fundamental rights and the impact of the people mostly within those jurisdictions. It's more difficult to have someone from outside of the jurisdiction to claim their rights in another jurisdiction. It might be possible with regards to damage, but it is another difficult hoop. But let's think about, all right, an obligation to stay on 1.5 and do adaptation. Well, what if the adaptation is insufficient? Right, so I think for scientists, it's important to start to assess, all right, what adaptation is necessary, what is being done, and what are the consequences of adaptation not being there? Because if there's an obligation to take adaptation measures, not doing that and damage that follows from that, there would be a liability. The other thing is, if there's an obligation to stay under 1.5, and we're already on an overshoot trajectory, and Rachel said something about the this Provide research group that's looking at what are the impacts of overshoot. And I would say, well, if your obligation is to stay below 1.5, and I think this is I'm going to go into one segue before going back to this Provide thing, but there is really a lot of more general reflection is that the scientific community is very much used to providing policy-relevant science. And that's often different from what we need as lawyers, right? And
And this overshoot issue is, I think, the best example of that. So you have climate scientists that say, all right, how do we stay on the 1.5? Well, we can't do it anymore within the budget, so let's just produce a pathway where we go back and we just imagine that there's going to be this technology that sucks it out of the sky. And that becomes the most dominant narrative, this pathway, of what governments need to do. But in law, right, if 1.5 is the limit, what we need as lawyers is to point at when the government is going through the red light, right? And that is not to stay on the pathway, that's to stay under 1.5. So overshoot is not a part of that whole concept. And I think if there's a fundamental rights obligation to stay on the 1.5, and a country goes over its fair share, then it becomes responsible for all the impacts that occur in overshoot, even if we then later go back to 1.5, right? Because their obligation was to stay under 1.5. Also, not just the damage from those impacts, but also who's going to pay for those negative emissions. And I think that this fundamental rights litigation might actually provide the framework to create that responsibility discourse. And I shared this one graph with these bars that nobody could really look at, but it's an important graph just as a concept, right? For any historic responsibility, however you imagine historic responsibility for the EU, the budget is already negative, right? So that means that there's a debt, there's a carbon debt on the European Union, and let me tell you, in the US, it's a lot bigger. And that means that debt needs to be paid by sucking the CO2 out of the sky, right? If that's your fundamental rights obligation to stay under 1.5, you're going over your budget, then you need to pay to suck the stuff back out, because we don't yet have a system to think about who's going to pay for those negative emissions, and I think that these cases might help to shape that debate.
No, and I totally agree. I feel these cases have reached the first step. They prove governments must mitigate and governments must adapt. But we are not in the other steps. We need to move forward, and we can use the same fundamental rights provided by constitutions to say there is a fundamental right to adapt, to really adapt. And we can prove how we can prove if a government is not implementing adaptation in a good way. Every time it's like slow onset events, we can adapt if slow onset events don't translate to disaster. And we are also adapting if extreme weather events, because the disaster is not an event, it's the consequences of the event. So if any extreme weather event occur, but don't become a disaster, okay, adaptation, it's well done. If the slow onset progress is occurring, but there is no such a thing like a disaster, governments are implementing. So it is a minimal level. But it's just thinking about government duties. But I want to just emphasize, government duties are corporate duties. We must think in a different way. When we say there is significant emitters causing the warming of the climate system, they are influencing in a different way in what's going on. So if you accept this first part, we can move forward and say, well, even if the governments do whatever they can to adapt, adaptation is more and more difficult because some people are accelerating the process of warming. And we can hold them accountable, at least in part, such as Vermont State just did, New York State just did. But it's accountable based on historical emissions. But I think we must improve this dialogue in the courts. We are in the first steps in these discussions. Yeah.
One very my question, and then my question to Angela.
Excuse me, if you could use a microphone so that people online can hear you. Thank you.
One question to Angela. A lot of the science is being done by federal and state government scientists who are, generally speaking, enjoined from testifying against other state entities for various reasons. Are there ways of getting around that? And then the second question kind of really relates to the 1.5 number. Like, so tomorrow we're going to announce that we likely went past that for the first time. But there isn't a fundamental right to stay below 1.5. That's not what's in the Paris Agreement. It's aspirational and not legally binding, that, for obvious reasons. And so, like, tying everything to the carbon budget for 1.5, I think, I don't think, as a scientist, I don't see that is a good strategy. And, that nothing happens at 1.5 that isn't going to happen at 1.5, 1.49 or 1.51. It's a political statement. It's not a scientific statement. Plus, it's only aspirational. So, like, how do you cope with that?
I'll answer the 1.5 question. Yes, we totally agree with you, and all of our experts have said the same thing. So we never ask courts to enshrine or adopt that as a protective standard. We ask the court to protect the rights of children, and that's getting off of fossil fuels as quickly as possible. So totally agree with you, and all of our experts have agreed with you in their testimony as well. And then the first question was, we actually have had government scientists have gotten permission. I want to say Eric Rigno got permission to testify years ago in Juliana, if I remember right.
He works for Caltech, not for the government.
Yeah, no, but it was before he was with I don't know, that's one that came to mind. And then Kevin Trenberth also was working for government, and he they would consult the general counsel office. And so we have worked in different contexts where scientists work with governments. But it's a really big deal in places like Florida, where we have state cases where there's, they're really getting threats. And so we can't work with any scientists associated with Florida or Florida State.
Yeah, Kevin worked for NCAR, which is not a government agency.
Okay, yeah, there was something, though, that he had to get some sort of permission because of a grant that he had. Yeah.
So on the 1.5, right? So the basis of the cases that I mentioned were not the Paris Agreement. Right? They were constitutional, so that's national, fundamental rights. That's another body of law. Right? So the Paris Agreement was very important as an interpretive source of that other legal norm, which was the fundamental rights. And what these courts have done is that they said, we look at a bunch of different sources, science, political consensus, the Paris Agreement, and we come to the conclusion, for instance, in the case of the European Court of Human Rights, but also in the South Korean Court, that their own national goals were 1.5. Their own climate acts said 1.5. Okay. So then the court said, if there was 1.5 in the Paris Agreement, in the COP decisions you keep mentioning that 1.5 is super important, you mention it in your own policy documents and in your own laws, I find that to become then the norm. Yeah? So that is now, in these jurisdictions, that is the norm. And I think that's hugely important because they can't backtrack from that, which obviously is going to happen, right, in negotiations. But in court, they can't. Because how can you now explain in the court that, all right, last week you thought 1.5 was the limit, and now it's no longer important? Why? Are fewer people dying, or what's happening? No, right? So the duty doesn't change. And that is important in the court of law, right? Not in policy, but in law, it's, did you cross the red light? Well, yes, right? So the budget, and that's why this budget concept is so important. And it was also so important, for instance, both in these cases. And so